Good morning, everybody. Can everybody hear me? All right. Valdemar, online looks good. Great. All right, everybody, welcome to the Center for Irrigation Technologies AgTechDay. We are really happy to have people back in person again. It's been a long 2 years doing everything virtual. This year, we're going to be doing things virtual and in person, so welcome again. Today, we're going to be taking you around to 3 different sites on the Fresno State Farm. We've got demonstrations of shallow groundwater aquifer recharge. We've got some demonstrations of stem water potential measurements and some drill and drop probes. And we've got demonstrations of flow meter installations and a short presentation on Sigma. So there's going to be some great educational content. We've got some great content from our sponsors. And after you visit each one of those 3 sites, we're going to take you across the street here. And we've got a little trade show set up here. You'll be able to see some of the latest ag technology, as well as representatives from the College of the Sequoias, the Irrigation Innovation Consortium, and Fresno State. So again, welcome everybody. I'd like to take a few minutes to thank our sponsors. First up is PG&E and Tom Sizemore, or Steve Sizemore, sorry. Thank you for sponsoring, and tell us a few words.
Good morning, everyone. My name is Steve Sizemore. I'm a Southern Region Lead for the PG&E Dig-In Reduction Team. And the goal of our team is just to help partner with the people that are doing any kind of excavation work out there to try to prevent damages and keep the community safe. So just a quick story. Recently, a grower was digging and working their field in preparation to plant a new crop. During that, they did not get a...
Hold it a little closer to your mouth.
Is that better?
That's much better.
There we go.
Thank you.
So recently, a grower was excavating and ripping their field to put a new crop in. During that time, this is something they had done many, many times and never had a problem. But recently, they ended up striking a 4-inch natural gas main, ripping it from the ground. In retrospect, they said they wish they had just called 811. That free service could have prevented this damage. And unfortunately, no one was injured. That was the best part of it. The pipe could be repaired, all that stuff could be repaired, but that calling 811 or getting online and submitting that ticket online could help save a life. So just wanted to help share that story with everyone and encourage you to call 811 prior to any digging. And there's a couple training opportunities out there. Our team offers free training. We will come to the site and present based on current events and current law. And then also USA North offers a free online training. It's called 811 Pro, and it's 811pro.com. Thank you all for your time. Please feel free to visit the PG&E booth across the street, and have a great day and a great weekend. Thank you.
Thank you. Thank you. So our next sponsor is Steve Huth from Technoflo. Steve, are you here? There you are. Thank you very much.
Thanks, Charles. Hey, welcome everybody. We're very excited to be here today, and thank you, Fresno State, for putting on this fantastic educational event. My name's Steve Huth. I'm president of Technoflo. Myself and my brother Eric have been in the flow measurement business for a combined of 70 years. We're not each that old, but put together, and we're very passionate about this industry. We are a master stocking distributor for the SeaMetrics product, which is some of the latest innovation in no moving part battery powered mag meters. Katie England from SeaMetrics is joining us via Zoom. Hey, Katie, good morning. Wish you could be here, but she couldn't. Anyway, flow meters, accurate flow measurement, and proper installation are some of the huge keys to getting what we need to help with the SGMA, the Sustainable Groundwater Management Act that we all are falling under. So excited to be here. We do have a booth across the way after the bus tours. I'll be at site 2 with Sarge Green talking about flow meters. He'll be talking about SGMA. Look forward to seeing you all out there. Thank you. Enjoy the day. We got a beautiful one.
Thank you, Steve. So we've got 3 buses over here. The buses are going to take you to each of the 3 sites. The buses each hold about 50 people. I think we should have plenty of room. And we've also got, I'm being reminded that you also need a parking pass. So if you parked out here and you didn't have one of the little yellow tags, Fresno State parking folks are going to come by and give you a ticket, and that would be awful. So parking tags are either up front or from the person who's standing right in front there. So whenever, oh, forgot, CEUs. If you need continuing education credits, the signups are right here at the front desk. We have CEUs for ILRP and Certified Crop Advisor. So again, welcome everybody. Thank you for being here, and take 1 minute to wave to everybody who's online.
Hello, my name is Elijah Banda, and I'm currently a student assistant at the California Water Institute located on Fresno State's campus. I'm currently a senior at Fresno State and will be receiving my bachelor's degree in city and regional planning with an interest in environmental planning. Today, I will be presenting on a project that I have had ample time to work on and cannot wait to share more about it. In the San Joaquin Valley, there's a new generation of progressive water resource leaders that are coming together for collaborative efforts. New leaders among the growers and agriculture industry, environmental NGOs, the safe drinking water movement, local government, and academic institutions are some of the individuals we've had the pleasure of working with. These are new leaders who are focused on making decisions collaboratively instead of through conflict. And this has given the San Joaquin Valley Water Collaborative Action Program the necessary momentum to spark lasting change, which for the purposes of this presentation, I will refer to as CAP. Has a goal to develop and implement a valley-wide comprehensive program that resolves the problems faced by all water-related interest groups to the satisfaction of each group and the collaborative as a whole. CAP is a program unlike any other and is still growing. The process is built around 5 interest groups, what I will call caucuses, that include safe drinking water and disadvantaged communities advocates, environmental NGOs, local city and county governments, growers and the ag industry, and water agencies from throughout the valley. The key decision-making body is a large plenary group with more than 70 members. The plenary group is co-chaired by Buzz Thompson and Ashley Swearingen, both of which are very dynamic leaders and help gauge the group. The planning group is organized by caucus and is a smaller group of more than 20 members. CAP also has a 9-member steering group co-chaired by Ashley and Buzz that includes representatives of all 5 caucuses. The primary job of the steering group is to review meeting materials going to the plenary group to make sure they are fair and balanced. The first step was to create a shared vision, which is ensuring a sustainable and resilient water supply for the San Joaquin Valley for multiple benefits by securing safe, reliable, and affordable access to water for drinking, sustainable and productive farms and ranches, healthy communities, and thriving terrestrial and freshwater ecosystems. Through months of discussion and debate, the CAP participants have identified 5 key problem areas. The first is the gap between valley water demands and supplies, and the gap is tremendous. PPIC estimates that the average annual groundwater overdraft is 2.4 million acre-feet annually. Local water managers believe it is probably bigger. When you add the need for water in valley ecosystems, the gap widens. It is so large that only a comprehensive solution set can hope to close it, as required by SGMA. Second, the valley has lost virtually all of its historic natural habitat. 18 species are listed under the ESA as endangered, and an additional 27 are at risk. Third, after years of farming, many communities, especially disadvantaged communities, do not have safe drinking water, and during the previous historic drought and this one, extensive groundwater pumping by farmers have dried up thousands of domestic wells. Fourth, much of the valley's water management infrastructure is aging. All of the major conveyance systems have lost capacity due to subsidence, in some cases by more than 60%. The valley's natural infrastructure is also in bad shape, in part because during the development era, flood managers disconnected the land from water. The fifth problem area is inconsistency among local, state, and federal policies, which oftentimes place a heavy unfunded burden on local government. During the period when CAP was developing this common problem statement, many participants were eager to start working on solutions. They got that chance in July. The work groups are essentially creating the solution set for the CAP Phase 1 report. They have been meeting for more than a month now. Significantly, every work group has cross-caucus membership, and with one exception, cross-caucus co-chairs. Work Group 1 is forging comprehensive water management strategies, which could lower demand and increase supply. Work Group 2 is focused on safe drinking water. Work Group 3 is working on environmental vision for the valley. Work Group 4 is an umbrella group that is envisioning valley-wide changes in land use. Work Group 5 will address implementation strategies that align local, state, and federal policies. And finally, all 5 work groups have 8 to 16 volunteers, and every group has representation from all 5 caucuses, and all of them are working very hard. This collaborative action program is envisioning a better and more sustainable future for the San Joaquin Valley while maintaining and pursuing a diverse community and economy. If you have any questions, do not hesitate to reach out to me or the California Water Institute for more information.
The Blue Tech Valley Initiative sparked an exciting movement to make the San Joaquin Valley the place to launch a business. A place where the most innovative thinkers can come together with experts from science, industry, and education to develop and market products to help solve the water, energy, and ag challenges facing the world today. The Blue Tech Valley helps entrepreneurs turn their vision into real-world solutions through the Water, Energy, and Technology Center at Fresno State. Join the movement. Learn more at bluetechvalley.org.
So good morning, everyone. The APEP crew is getting the mobile educational studio set up at Site 1. They will be coming online very shortly. Again, thank you everybody for being here, and we're glad you could join us on Zoom. This first site is going to be about a research project that's being conducted by Cordie Qualle. And in a few moments, I'm going to hand MC's responsibilities over to Bill Green, our education manager. He's going to introduce some of the speakers, and he's going to take it away momentarily. So again, Thank you for being here. And there is Bill, and I think he's about ready to get started. Bill, can you hear me?
Yes, we can hear you, Charles. Thank you. And thanks. We're out at field site 1 here next to the Young Almond Orchard. And we have two speakers here. We're going to start with Qualle from Fresno State. He's a professor in the engineering department, and he's got a project out here for groundwater recharge he's going to talk about. And then he'll hand it off to Greg Allen from REDtrac, who is doing some of the telemetry and some of the hardware out here and software too. So that's tracking this project. So we'll get everybody exposed to that. And hopefully you'll be able to see what's going on here with Valdemar on camera and Kayla in the production booth there. So, okay, I'm going to hand it over to Cordie here. I got my phone in my hand. Sorry. I got to wipe this down and hand it to him.
Thanks, Bill, and welcome everyone. Thanks for coming this morning to see our project. And I am Cordie Qualle. I do work at Fresno State. I am in the civil engineering department. I've been interested in groundwater recharge for about 45 years. I did grow up in the valley here. I'm a valley boy, born and bred. In fact, my father was born here, so I have deep roots here. And I come from the Modesto area. Grew up in a little farming town called Huth, California, and came here to Fresno State and have been here since then. I live in Clovis, as a matter of fact. In 2017, we had a banner water year, but the 3 years before that were probably one of the poorest water production years in California's history. And so what that got me to thinking was, as I watched all that water roll down the San Joaquin River, I was thinking, well, I wish we could capture some of that water. I wish there was some way to get that water into the ground here so that we can use it. Also was very much aware of the fact that we are having a problem with groundwater depletion. So the two things seem to go together, but the problem was, how do we mobilize land in order to get that recharge to happen? We've got an incredible distribution system. You can see part of it here, the Helm Canal, which belongs to the Fresno Irrigation District. It has water in it when we have good water years, usually from about mid-February to sometimes as late as October. This year, water was quite late and they shut it off quite early. But if we had access to surface water and we had access to agricultural land, how do we get those two married up together so that we can do recharge? We do know that from the SAGB information that about 60% of all the agricultural land in California is viable recharge, either good to moderate recharge capability. So how do we get that into mobile? How do we mobilize that? How do we make it available? And then how do we also do that without disturbing your operations? How do we get that recharge to happen while you still do your farming operations? And so it occurred to me, you know, there's a chance to do that if we could put that water underground and basically do a leach line. And that's all we're doing here is a reverse tile line. So some of you are familiar with that tile line concept, where what you're doing is picking up that tail water that's percolated down through the groundwater from your irrigation, take it off because it's salt laden. Well, what we're doing is putting high quality surface water into the ground under the surface. And that does a couple of things. One, it reduces the amount of loss we have to evaporation. We're also below the root zone, so we're reducing that ETO loss. And the third thing is we are down below your operations, so you can continue to do your work. I thought this was a really cool idea and pitched it around, but couldn't find anyone who was interested in it until I had a grad student wander into my office one day, Gabriela Bonilla, and she's acquainted with Greg. She worked for Water Associates down in Bakersfield. And she said, oh, that's a really cool idea. In fact, my boss has one in his orchard. And I went, what? How did that happen? So we started talking and met with Greg Wegas down in, I think it was Wasco area. And he showed us his field. He had 40 acres of almonds down there, and he had a full system in there. And he said, I'll connect you with a guy named Glenn Down from Lidco. We connected with him, and he said, yeah, I put these in. I put in Greg's. And so he volunteered to install a system here for us to use for research, because there's no science in this. It's just he's installing these systems, and we want to know how much waters are we putting in the ground? Is it economic viable? And how do we make this, how do we optimize it on a design basis? So that's what we're doing here with this system. Greg came up, Glenn came up with his crew in October a year ago. There was nothing here. The trees weren't planted yet. And what he did was he brought up some trenching equipment. You can see a picture of it here. And basically he's installing using a trencher to install a continuous perforated 4-inch pipe out here. And they run in the aisles in the rows between the trees. And so in order to do this, we need to have a clear field. This type of equipment is so large, and we're also moving this tailing material around with loaders. So we've had to do this before we planted trees. They do have equipment that will do it with it in a planted orchard, but it's just a little more cumbersome and a little more expensive because of the additional logistics. But anyway, it's basically a cut and cover. In other words, this pipe is being, the trencher is cutting the trench. The pipe is being fed into the bottom, into a gravel envelope at the bottom of the trench. And then there's a loader that's right behind. And so it's cut and cover. It took about 2 days to install the system we have here. We have 3 lines running down the rows. So basically what's happening here is we've got a connection to the canal here at the turnout. And then we bring the water into the wet well. We're lifting it out of the wet well, bringing it through our filter system right here, which in this case is just a spin filter. If you were going to install this in your orchard, you'd probably send it through your drip line filters. We have a water meter here, which is solar powered and hooked up to a Davis system, which is then fed into REDtrac. We distribute the water over to our standpipe over here behind you. And from there, it's gravity fed to our leach lines that run down the orchard rows. You can see the turnout where we have a valve on each line so we can isolate the lines if we want to for research purposes. That's not normally done in a field operation or installation, but we want to be able to isolate our rows and look at information. We've also out in the field installed a series of probes, moisture probes, and here's their Sentek probes and their EnviroScans. You can see them here. Greg brought one of them here. Ours are 30 feet long, or about 10 meters, go 10 meters down. This is a 4 meter one, or not 4 meter, I mean, sorry, it's about a 4-footer. And you can see these are capacitance driven meters. This sits in a side of a PVC casing. So you put the casing in the ground, then you drop the this installation in. It gets hooked up to a data node, which looks like this right here. And we are using Davis data nodes for our system. Each of our probes has one of those. We have 3 of them out here in the field, 1 for each leach line. And we are reading that data. It's being collected by Davis, and then through an API connection, it's going to Greg and Greg's system, REDtrac, who is our data aggregator and platform, and also helping us with our analytics. So the system basically looks like this. As I said, we collect it out of the canal, we put it into a wet well, send it through a filter, through the meter, into the standpipe, and then out through the leach lines. And you can just see in this graphic depiction how the water is coming out of the leach lines and going into the aquifer. We do have our moisture probe sitting here going all the way down 30 feet, and they are showing us how that moisture front is progressing and how that moisture is sitting in terms of the saturation of the soils. One other thing I didn't say is before we started this work, we came out with more Twining, brought out their drill rig, and we drilled a 50-foot deep boring out here to check on the stratigraphy, basically the soil layering as it goes down, to make sure we had good soil strata for recharge efforts. And then we took all of that soil samples, all 25 of them, into the lab and did sieve analysis, plastic limits, and also we are working on hydraulic capacity. So that was pretty much it. Our I don't know if there's anything else I can tell you or answer for you. Do you have any questions? I don't know how we're doing on time. It's about. So How much water can we put in the ground? We figure we can do, we have about a 60 gallon per minute pump here. So our system will absorb at least 60 gallons per minute. We've not had any problem putting that amount of water in the ground. Basically, you're limited by your pumping capacity. And the reason we do this is because when it comes out of the canal, although the water's high quality, it also has some silts in it. And we want to remove those silts and make sure that we're not plugging up the soils as we leach this water, send this water into the aquifer, because that will reduce our capacity and our ability to move water into the aquifer. We ran for about 2.5 days solid this year, and we put in just under 3 acre feet in those 3 days. But again, we're moving a fairly limited capacity of water because we're in a research situation, not in a full recharge situation. If you had this full 80 acres engaged, you could probably put some significant water in the ground. And so, I didn't run the numbers, but you could potentially run somewhere up around a 200 acre feet or more without any problem. Yeah. Okay. So, yeah. The question was, how about the economics? That's part of what we're trying to establish. So we're looking at what does it cost to install the system? We know what that cost was because LEDCO provided that to us. What did it cost us to do the installation of our distribution system, pump wise, et cetera? And then we have our sort of operations costs, which we're looking at the power consumption and that type of thing. And then also we're going to look at that against what we think is our recharge efficiency. And we're going to look at it on a dollars per acre foot basis. But just to kind of answer your question, if I remember right, Glenn had mentioned that the cost to install the system is about $4,000 an acre. So, but when you start looking at what is it going to cost you to farm with if you don't have water in the ground, it gets a little bit, interesting at that point. But what we want to do is show that this cost on a per acre basis, we hope will turn out to be just as economical as any other option that you've got. The other options out there are deep water injection, which is basically you need drinking water standard water to do that. Well, that's not quite as available to us and it's expensive to produce. The other one is to put it into a basin, and of course, who wants to lose their land to a basin? And you end up with these basins all over everywhere, and you have to then maintain them. And so what we're after is, can you become part of the recharge solution in your fields without losing the ability to farm and take that land out of the tax rolls? So, yes, sir. What's artificial about it? Well, it's not natural recharge in that we aren't recharging water that fell from the sky and went into the ground and then percolates down or infiltrates and percolates. So reason we say it's artificial is because it is water that we are applying to the ground that didn't originate there. Managed, you could call it shallow subsurface managed aquifer recharge if you wanted to call it SSMAR. We just came up with this. Okay, thank you. Appreciate that. Yes. So the question is, how deep is the water table here, and are we measuring the effect on it? And the answer to the question is, we're somewhere between 90 and 120 feet deep here to groundwater. And we don't have a direct connection to the groundwater system, so we don't know what its quality is, et cetera. What we're trying to do is see if we can measure with our Sentek sensors that the water is going down from our source and it continues down, then we're assuming that it's going to make it all the way down. Yes, sir. The question is, can we install this system where it's already been planted, like in an almond orchard that's already established? And I've been told that that equipment is available. In other words, this is a huge trenching machine right here. It basically takes up a whole aisle. But I understand that there are narrower trenching machines that can do the work. The logistics get a little bit crazy because of the movement of the materials and whatnot, but it can be done. It's just gets more expensive.
Cordie,
the best time to
sorry.
go ahead.
Cordie, this is Charles. There's a question in the chat. I'd like to read it to you.
Go ahead.
Okay, the question is, can you recharge your fields by subsoiling the land? Do you have any land available that you can recharge by subsoiling?
I'm not sure what subsoiling. Oh, ripping the ground. Okay. Yeah, you can. That would involve getting, that basically what we're talking about is a flood situation there where we're basically flooding the field with excess water, and that's fine. It's a technology that's being used, and in fact, DWR is studying that quite heavily. The difference between our system and that is that we are doing it subsurface so that it's already below the ground level, and we aren't interfacing with your operations, the farming operations, but we're also not interfacing with any of those residual chemicals or nutrients that are in the soil and leaching those down into the groundwater, which is something we want to avoid. And we assume you'd like to keep that stuff on the surface if you can. So I don't know if I answered the question, Charles, but I gave it a try.
It sounds answered to me. Thank you.
Okay. I'm going to over to Greg, if I can find the right place to speak. And, Greg's been a great partner here. He came in at the very beginning. The encouragement we got from him was incredible. Doing here is because he's encouraged us all the way. So Greg, get away.
Good morning. Quick show of hands. How many folks here are farmers, growers? How many are hardware people, sellers, retailers, or sellers? And how many of you are academics working for the university? So, all right, we're talking a little inside politics here when we're talking between the suppliers to suppliers. So let me expand a little bit before we talk about REDtrac and what we're doing here about some comments we've had and other experience with other growers who have recharge. And what we've learned in the several projects that REDtrac has been involved in is that it is critical to know your stratigraphy before you invest a dollar. The first project we were involved in was the family-owned project in Wasco, the 40-acre almond orchard. And they discovered after the fact that they had a clay layer down about 8 feet. And so they had wonderful recharge to 8 feet, and then the water started backing up into the roots of their young almond orchard, which was not what they had intended. And so based on that water district that land is involved with now requires that if you want to do a subsurface recharge program, you have deep cores dug, or with small cores down to 100, 200 feet, and do the soil analysis so that you know that you're not going to run into a shale break and simply be bouncing water up or pushing it into your neighbor's farm next door. It's an interesting proposition how recharge will work. If you assume that some 20 to 30% of land in the Central Valley will be fallowed, what happens to that land? And farmers or growers are talking about what are their alternatives? Can I put in a solar farm there? Can I put in some kind of carbon sequestration? Can I put in subsurface recharge? Can I dig a basin and do surface recharge? And if so, what does that money amount to? If an acre foot of water is worth $600 in today's market, just for the sake of illustration, it's going to take you a long time to pay $4,000 worth of per acre of installation costs for subsurface recharge. So the numbers for this aren't compelling just yet, as far as the economics are concerned, but the science is clearly there, and that's what REDtrac is helping with. So when Cordie explained to us that he had the option to put in 10-meter probes, which is 39 feet, that's a long ways down. And watching the progression of water every meter that's applied at the surface and 10 feet down, and seeing how that affects roots and recharge is fascinating. And for those of you who'd like to see the results of that, come by the booth at the wet center later after lunch, and I'll show you the actual graphs where we can see the infiltration of water. The first probe sensor, the little capacitance sensor that Cordie showed you a minute ago, is down about 40 inches. And then every meter, there's another probe. And so when we see the effects of surface irrigation as well as the subsurface irrigation, we happen to have a sensor down just at the point of the recharge line at 10 feet. And so we can delineate between what the surface rainfall and the surface moisture is, surface irrigation, and what the recharge is. And it's a fascinating combination. Cordie didn't mention that this soil is very sandy, as I understand it. Almost no clay or loam in it at all. And so putting a gallon of water on the surface is going to pretty quickly go down deep. And we can see that even with the rain this weekend. The rain from the past few days got down to below 36 inches almost immediately. And that would lead me to think that these trees are going to need shorter periods of irrigation, but more frequent irrigation to keep the roots wet over time. We'll see how that goes. That's an interesting, the field behind us has got shallow soil moisture probes that were put in by a competitor of ours. I'd like to be able to bring that data in so we can see the shallow versus the deep. One other issue that Cordie mentioned that I thought we would take up is not far from here. REDtrac has a demonstration project on what they call well number 2 by the Jordan Agricultural Research Center. If you'd like to go by and take a look at that well, I'd be delighted to show you the equipment. It's fully equipped, and working with Bill Green, we were able to do real-time overall pump efficiency calculations on that well. Fascinating. The water depth is a critical key of doing OPE calculations. And so we have a continuous water depth monitor on that well. And we can see the water moving from about 100 and, if my memory is correct, about 140 feet downward as the pumping season progresses. You can see it in real time moving up and down as that pump kicks on, the electricity kicks in, the head steps up, the water level starts creeping down appreciably. And over the course of the season, the standing water level after each irrigation event goes down a little bit further. Then over the course of the winter, if there is a winter weather, that water comes back up to the standing water level. So if we can assume that we have a heterogeneous subsurface between here and well number 2, which we probably don't, but if we were to assume that, we can watch the water level at well 2, which is, what is it, 1.5 miles from here, Cordie? Something like that. You can almost see it at the JARC Center from here and watch the water level go down. The deep water measurement to figure out what you actually are going to recharge into the subsurface is not a practiced art unless you happen to have an abandoned water well nearby that you can check water level frequently. We haven't run into that circumstance just yet. So let me stop there, and then we'll talk a little bit about REDtrac and our history and what we provide. Are there any questions so far for either one of us now that we've got a tag team going here? The question is, if you have a production water well, can you use the same well to recharge? I'm going to let Professor Qualle answer that one.
Well, actually, they are doing that, but it's strictly regulated by the Water Resources Control Board, and the quality of water that you put in the ground has to be at or above drinking water quality. So you know, basically, if you pull it out of the ground, you got to treat it before you put it back in the ground to prove to them that it's better than drinking water, because they don't want you putting something back in the aquifer that would degrade it. If you were down in Orange County, they have spent millions and millions of dollars cleaning up their wastewater and then injecting it, and deep water injection. So the technology is usable, it's there, but you're talking water that's pretty expensive per acre foot.
The water district Cordie referred to as Orange County Water District, and they are a customer of REDtrac, although we're not involved with the reverse osmosis project. And it is true, they will not even bother to calculate what it costs them per acre foot of water to re-inject. But their goal is to keep the Pacific Ocean from into the salt water in the subsurface layers from getting into the freshwater aquifers for supply. So it's not truly a recharge, it's a picket fence defense of keeping the salt water at bay, literally in the bay instead of in the groundwater nearby. So REDtrac is a 10-year-old company. We started exactly 10 years ago this month. We began as a remote engine diagnostics company, and hence the name RED, Remote Engine Diagnostics. And we began by tracking the location of rental pumps. The rental pumps had a tendency to get stolen, and we put GPS tracking units. Discovered along the way that those folks had to turn in air quality reports, and we put in diesel monitoring systems and had that all come into our system. Then we had customers who wanted to measure their tanks, and so we got into the propane and liquid tank monitoring business, and we have literally hundreds, maybe thousands of those that we monitor on a daily basis until the propane companies and the liquid distributors and fertigation companies, when they need to go back out and refill their tanks in the field. We also track thousands and thousands of nut trailers. Many of those trailers have load sensors on them, so they know the Wonderful, for example, knows where their trailers are, and if they're not being used, they'll go back and pick them up, and they know how many pounds of almonds or pistachios or whatever they're harvesting is in each one of those trailers when it comes across their gate, and what the turnaround time is. That led us about 6 years ago to start wanting to get into the ag tech business. The technology finally came along so that the equipment costs were reasonable. They were still high, but they were reasonable. And we expanded significantly then and began development jointly with another company of a platform for that. And our initial impetus was in soil moisture. We probably have as good or better soil moisture monitoring system as anybody in the industry. And over time, as additional technologies have come along, we have layered those into our system, starting with water flows. We have satellite telemetry now and can bring in vegetation index on top of your water flows, put ET on top of that, all in brilliant colors, and flip back and forth between the various screens and over time to see how your crop is doing and what needs to be done, both in the way of water application and fertigation. It's fascinating to see on the vegetation index maps that red spot in the middle of your field. And you don't know whether you've got a broken line or you've got a sand lens or you've got gophers or what, but with that, you can at least go out and figure it out. We're starting to have customers, having been in the business long enough, the customer cycle is that many of our customers are starting to push their orchards over and planning how to put their irrigation systems back in place. And to the question earlier, the best practices for the farmers who are very long-term thinkers is to push their orchard and then do a detailed soil analysis. They'll do a soil analysis every 10 or 20 meters in each direction. And with that data, you see not only soil composition, clay, sand, and so forth, you'll see exactly with the chemical composition, where do you need more potassium and so forth. From our perspective, it's a great indication of where we should put soil probes. Do you want a soil probe in a sandy area, a clay area? Where do you want it? Because you want to know what your depth to water is, what the water looks like across your roots. In the past, we typically saw folks putting in one soil moisture probe per 80-acre block. In today's world, with the cost of soil moisture probes coming down and down and down, farmers are often putting one on each irrigation line in various points in the field based on what kind of soil type they have. And a few years ago, when we started the business, this 1.5 meter probe was about $2,000. In today's world, you could probably get it for about 2/3 of that price. Of course, the question is, do you really need a sensor every foot? And maybe you don't. Maybe you have a variety of different depth sensors throughout your field so you can interpolate between those points. So if you assume that you're going to lay out your orchard, your field, your crops, whatever you're putting in, Do you then want to put your irrigation set to match your soil type, or do you want it to match your geography? And so the question is, in the past, everybody's been rectilinear, one line, one row. And we're seeing some farmers not yet do it, but talk about laying out their irrigation systems using soil type. So we're going to irrigate one way based on sandy surface. We're going to irrigate another way in the loam and another way in the rocks. And you see that particularly going on in the high value crops like wine grapes. They're very particular about how that water goes in. The alternative to laying out Ichabod looking irrigation sets is to be able to control each irrigation set separately in line. So you can turn it on and off. Those devices are coming onto the market at a price that makes them economic. At least that's our hope. So how does all this technology fit? Well, most folks end up getting deluged with data. What do I do with it? How do I manage it? Who's going to do this? Do I get it by email? Do I look at a chart? Is it on my cell phone? What? And the answer is yes to all of the above. We joke around our shop that farmers want to run 10,000 acres on a 10 square inch cell phone. And we're just about there. You can almost do it. You can turn things on and off. You can see graphically what's going on. You can see numerically. The only thing you can't do very handily is print it out. In our system, we're real happy with the fact that farmers can go into the field, or their irrigators can, and they can see a problem. The system will locate them GPS and say, you are in block so-and-so, you're probably on line 6. And you can take a picture of that leaf. You can take a picture of the meter. You can make a note about what happened. I was here on Tuesday. The meter wasn't working. The well was running, whatever the circumstances are. And that's a permanent record in your crop cycle. So the technology is advancing, it's cheaper, and it's better attuned to farmers' needs. So those of you who've heard me speak before, you can yawn and scratch and go talk to Cordie if you'd like, but I want to give you the 2-minute REDtrac rules. And the REDtrac rules are: decide what information you want to fix a problem that you have. The corollary of that is, don't worry about the damn equipment until you've decided what software you're going to buy and how you're going to use it. Most of us farmer and guy types want to know, they want to go pick up this is heavier than that, this costs $12, that costs $15, which one? Forget the Legos, figure out what the design is and start there. And then work backwards to figure out, to backfill what the equipment is going to look like. Sorry, equipment manufacturers. Number 2 REDtrac rule is deal with somebody that you know and that's well capitalized, that's going to be around every day for the next 10 years. Well, you don't want to wake up expecting to see your applied water report and get a blue screen that says, we are taking other opportunities. Please call this law firm for further information. Get a well-capitalized firm, ask them questions, find out what their balance sheet is, find out what their burn rate is, in addition to what the neatest gizmo throttle nucleator they're selling you to run your crops. So I'm being told that I have to quit. I have 3 minutes left. And if you guys want to ask questions of Cordie and me, now's a good time. Thanks for playing along.
Yeah. So for the
Yes, sir. The question was how Bill was asking specifically about well number 2 and how it is performed. And then the general question is how are wells reacting to the long-term drought? And the answer is water tables are falling still. We like to remind people that we have a sustainable groundwater management act. It's not a sustainable evapotranspiration act. It's not a sustainable surface crop management act. It is groundwater management. And the key ultimately, the acid test is, are we maintaining our groundwater levels at a sustainable level, whatever that means? And the answer is, in most overdrafted areas, they are not. They're not getting better. And you can see that not only from looking at groundwater depths, which it's unusual for farms to have groundwater depth to water measurements, but you can look at the cost of your electricity. And as your electricity costs go up, as your usage goes up for the same volume of water, you know that that the water table is falling. And if you wanted to back into it, you could do a rough calculation of that. Looking at an assumed pump efficiency and your number of kWh and your standing water level, as you saw the kWh usage going up, you could calculate what the water depth was doing in very rough terms. But in general, I think the water tables are continuing to go down, and we are going to have a lot of very wet years to recover. And it seems inevitable that there's going to be some land fallowing. And the question is, what's going to happen? Are we going to put in solar farms, carbon sequestration, used car lots, subsurface recharge? That remains to be seen. All of those are likely options with the exception of the used car lot.
We've got one question online. Are you ready for that one?
Yes, sir.
Okay, I'll read it to you. This question is coming from Roxy Evans. The question is, irrigation efficiency is the key topic today. Just wondering if farmers are also looking for alternative water sources or interest in technologies that, for example, will reduce the needs for evaporation ponds or turn the salty or unhealthy water from the evaporation ponds for irrigation.
I think the answer is yes. It's all of the above is the typical response we get. There are while it's not my business, I follow it carefully to watch different trends for how people are proposing to put surface layers on below crops on the ground to retain moisture in the ground. We see a lot of motion in trying to reclaim water through either membrane technology or reverse osmosis. There are some chemical, there's a large group of researchers at Stanford that are working on chemical treatments of water, both salt water, brackish water. So I think that is something we're going to have to figure out. The problem is, of course, if you're going to recharge that water, if you're going to put it in the subsurface, you're going to have to meet very high standards. Otherwise, if you're trying to do surface recharge, you're relying upon Mother Earth to cleanse that recharged water as it goes back into the aquifer. Closing remarks, Cordie?
Charles, in response to that question, also here at Fresno State, they are doing some work with, gosh, I just lost it, resin exchange, resin ion exchange to clean up water, remove salts from evaporation pond water. And it's just starting to get going, but the promise there is that we can reclaim some of those salts and reuse them at that have economic value to us. So we're not only getting the benefit of the reclaiming of the water, but also some economic benefit to the reclaiming of those salts. And it's in a pilot status. It'll be starting fairly soon, I think, if I remember right. And we hope to see some good promise from that. But that's being funded through, I think it's the Lawrence Livermore Laboratory people and the federal government, of course. So there you are.
And that's Carl Longley is the lead researcher on that one?
That's correct. Yeah, Carl and I think Walter Manzuno and Bill Wright, and there's another researcher, and I don't know his name because I've never met him, but he's from the UK. So it's a good group of people.
Yeah, so if anybody would like to know more about that particular project, just search online for Dr. Carl Longley at Fresno State. You'll find his contact info.
Oh, yeah. Yeah. So the question is, have we looked at grants to pay for this system? And yeah.
Okay, very good question. So yeah, is there grant money available to help a farmer install this type of system? I believe is what you're asking. Yes. Yeah. I'm not aware of anyone that's looking at this seriously from a grant funding standpoint. We hope that we can show that this is a viable way or feasible way to do recharge, and therefore grant funding might follow as a result of our work. But right now, our system was installed as a part of the Agriculture Research Institute funding. So we did a grant from them to do our system and do the research work. But for a commercial installation, I'm not aware of any grant funding sources at this point. I wish there were. Right now, the farmers that are installing these systems down in the Bakersfield area, basically it's coming out of their pocket, but they feel it's in their best interest to do that. Sure. So the question is this a viable technology for doing recharge that would help prevent subsidence, particularly over on the west side and where these areas where we have a large amount of subsidence? A tricky question to answer because subsidence is a multi-dimensional type of problem, but it certainly in terms of replacing water that's been lost in those aquifer layers that will rebound, yes, it would stop and help retard that type of subsidence. And those aquifer layers that are basically the clay layers where we've lost that water and it's probably not going to come back, we wouldn't be able to reverse that. But we feel it's a viable technology for doing recharge in any water you put back in the ground. If that aquifer will rebound elevation wise, then yes, I think it would help. Did I get at your question? Okay. Yeah, I'm sorry.
So we've got one more question online if you've got time for it.
Oh yeah, we're okay.
Okay, so the question is, how do you use Davis weather monitoring equipment in what you do? By the way, this question is coming direct from Russia. We're glad to have some international attendees.
From Russia with love. Okay. The Davis equipment is, we are also hooked into their weather station, which is here on campus. It's about 1.25 miles away. So we're using that information. We don't have a Davis weather station situated right here at our site, but we feel like this location is close enough where the weather station is that we can use that data reliably. And it's going into Greg's system, I believe. So let Greg talk about that a little bit.
That's correct. We recommend Davis systems to many of our customers as far as the weather is concerned. They're reliable. They've been around a long time. The newer systems typically have non-tipping methods, non-tipping rain buckets, which are nice, but they cost more. So Davis is a good choice for customers. And yes, we bring that data in along with the flow. We haven't really talked about what we're calculating, so let's spend about 30 seconds on that. I believe this is a SeaMetrics meter, 2-inch plastic meter, which more than likely was sold or provided by Technoflo as part of the system, is hooked into our system, as well as a pressure transducer at the back. So we can tell when the pumps are flowing, how much you're putting in into the ground. And when we have rainfall from the station, we'll show that as an input event as well. So the duration, the amount and the duration of the event are shown as a height and width figure in the chart, above which you have the soil moisture probe at each depth and how that water infiltrates over time and affects the field capacity at each depth. And with that information, we can calculate the amount of water that's put into the ground and the amount of water that's making its way into the aquifer. And I think we're about out of time, Bill. All right, good. Yeah, last questions and comments for the professor. Yes, sir.
Well, that's a good question. The question was, where would you install this? Or what would a farmer who's contemplating this type of system, what do they need to know in order to install it? And where would it be ideal for them to do that? Okay, so first thing would be, is the soil appropriate? And this is, Greg talked about the stratigraphy of the soil as you go down. So stratigraphy is just a fancy word for what is the layering of the types of soils that as you go down between the surface and the aquifer. If those soils are appropriate for recharge, and we think that somewhere around 60% of the soils that are in agricultural land are appropriate for recharge type of work. That's the first step. You can do that through checking the SAGB site and just Google SAGB, SAGBI, and it will take you to a map that shows you California, and you can see where you have adequate, appropriate soils or not. The second thing would be to do a deep boring. We recommend that. So you're going to bring out a geotechnical firm. It's a $3,000 or $4,000 operation, but they will drill a hole for you and tell you exactly what the stratigraphy is as you go down. We did a 50-foot hole here and found we had good soils. So the next step would be, hopefully you would be starting with a vacant field instead of a planted field. That would be the best situation. And you'd want to meet with a contractor, someone like LIDCO, who's done this before, who's capitalized, has the equipment and the know-how, and work with them to lay out the field, and they would do that based on the amount of water that you have available. And that would be the other situation would be, do you have an adequate source of surface water that's nearby? Because obviously you don't want to pump it out of the ground and put it back. That's trying to do a perpetual motion machine that doesn't work. But if you've got adequate surface water supplies and you've access to that, then that would be another situation. You can, the third one would be, if you're probably going with a new field, you're probably going to do drip. And so what you would want to do is hook up your system so you can run it through your filters when you're recharging, and then flip that system over to your drip system when you're irrigating. I don't know if I answered your question, but that. Gosh, I'm not familiar with how you install underground drip, but the question was, can you install underground drip at the same time you're installing this system? And typically this system, the way I've seen it installed so far is it's about every 3 or 4 rows. So that wouldn't probably work very well. It's not like it goes down every row, and we're down the middle of the row as opposed to adjacent to the trees. But as long as, I don't know if that would get the water to the roots on a drip type application. I would assume not, but I don't know. I'm not an agronomist person. Sorry. Yes, sir. So the question is, what does the maintenance look like? And so far, the maintenance has been very simple. We just shut the pump off, make sure the system's drained down, clean the filters. In this particular filter situation, I basically pop the baskets out and take them home and pressure wash them and then bring them back. But on a standard filter, it would just be a standard backfill or backflow cycle. The other maintenance it's pretty maintenance free. Once it gets out into the field, you don't really have to do anything. In fact, you can't access anything anyway, hardly. So it's pretty much there. So besides making sure the pump is operational, the filters are clean and operational, that's pretty much it so far. How are we doing? Yeah, Bill. Yeah. So the question is, how does this system interface with the irrigation cycle, and particularly in those early months when we have a lot of rain?
and the fields are wet, and you probably might want to be doing operations out there and not wanting to flood them. So our system, because it's below ground, you can recharge starting as early as there's water available to you. And when we have really wet years, I know that water can run as early as mid-February, but we can start recharge at that point as soon as there's water available to us. We're not impacting the operations in the field because we're below ground. As long as there's water available to you for recharge purposes, you can recharge all the way through the entire irrigation season. Yes, sir. Yeah. Well, I do know that down in the Wasco area where they do have a Corcoran clay layer, when they start doing heavy recharge work, you can see that come up. And when it gets about 8 feet to 9, well, I was heard they shut off about 8 feet, but you can see the water come up to about 8 feet, and they'll shut off at that point because they don't want to drown the trees. So it can happen, and that's why you want to monitor that. No. We are seeing basically it going down, and we feel like there's a little bit of lateral also happening out here, but we haven't seen it come all the way up yet. No. Is that it? We're good? Well, thank you everybody for coming, and we appreciate your attention and your good questions.
I thank you, Cordie. Thank you, Greg. Really appreciate it. So you'll have another group in about 10-15 minutes. So we're going to get ready to move on here to our next spot. So hopefully the control room is ready to go, and whatever you guys are doing in the meantime. So anyway, thank you so much, guys. We'll see you in a while.
Okay, everybody. While the APEP team is packing up and moving on to Site 2, we will be showing you some more student presentations and informational videos during the intermission. We should be showing these videos for about 15 minutes, and we will be starting at Site 2 at approximately 9:35. So please stay on and enjoy these videos. Thank you very much for attending.
Hello, my name is Mary Church. I am a graduate student at Fresno State in the Civil Engineering Department. I'm currently pursuing my Master's of Science in Civil Engineering. As part of my degree, I am working on my graduate culminating project with Professor Cordie Qualle. The title of my research is Shallow Subsurface Artificial Groundwater Recharge at the Fresno State Farm, or SAGR for short. I've been working with Professor Qualle and his team on this project for a little bit over a year now. I joined last fall, right after they had received grant funding to install a SAGR system at Fresno State. And I wanted to discuss why this research is important and a little bit about why we're studying this system. Approximately 20% of the world's fresh water is pumped from groundwater sources. 40% of water needed to irrigate crops worldwide comes from groundwater sources as well. Several different industries rely on groundwater, especially here in the Central Valley: urban, industrial, agricultural, and environmental. As a result of this, we are experiencing increased overdrafting. Overdrafting occurs when more water is being pumped from the groundwater aquifers than is being replaced either by natural or artificial recharge methods. I've listed a couple of the detriments that come from overdrafting, such as land subsidence, decreased water quality, and seawater intrusion. The Central Valley consists of approximately 52,000 square kilometers of land. Of this 52,000 square kilometers, about 30,000 square kilometers is irrigated. Agriculture is a big part of the Central Valley, with about 250 crops grown here, and 50% of all of the fruits, vegetables, and nuts supplied to the United States grown right here. As a result of this, groundwater depletion has been increasing. Rates are estimated to be as high as 3 cubic kilometers per year. In 2014, California passed the Sustainable Groundwater Management Act, or SGMA, which requires that basins throughout the state meet sustainability goals over a 20-year period. For this reason, it's really important that we look at new and different ways to provide artificial recharge. One of the ways that we're proposing to do this is using a SAGR system for shallow subsurface artificial groundwater recharge. These types of systems are perforated pipe system, and they're currently being installed in farming installations in Kern County. With a grant funded by the Agricultural Research Institute, we've been able to install one of these systems on the Fresno State Farm. Our project site is shown in the map to the left and is located at Bullard Avenue and Willow Avenue. It's actually an almond orchard, and we installed the system last fall prior to the trees being planted. Here's a schematic of the water movement through the system. What we're doing is pumping water, excess surface water from an irrigation canal. We pump it through a filtration system and into a standpipe where it flows out into the perforated pipe system. Now, the perforated pipe system is installed below the root zone at approximately 10-foot depth. We have 3 lateral rows of 300 feet of this perforated pipe, which can each be isolated utilizing valves. The important thing is that because this is installed below the root zone, essentially it doesn't have any interference with the farming application above. So we're getting dual use out of the land with simultaneous farming and recharge occurring at the same time. Some of the other system components that we have installed as part of this project are the Grundfos pump. Lidco is who manufactured and installed our perforated pipe system. We have installed 3 Sentek EnviroScan soil moisture probes. Essentially, these are 30-foot deep soil moisture probe arrays. Each one of the probes has 10 sensors on it, which reads volumetric water content. I believe they're spaced every 3 feet apart. We've also installed Davis Instruments EnviroMonitor Gateway and nodes. These help our Sentek EnviroScan communicate with REDtrac, which is our data aggregator and analytics platform. We're also using a Davis Instruments weather station to collect information on precipitation, temperature, wind speed, etc. In this photo, you can see the Soil Agricultural Groundwater Banking Index, or SAGB, for our project site. It's highlighted in blue. Where we have installed the project is considered excellent in terms of the potential or suitability for managed aquifer recharge. The important thing about this is that we installed the system in an area that's going to have high infiltration rates and give us the best movement through the soil in order to get that deep percolation of water back into the water table. Approximately 22,662 square kilometers of agricultural lands statewide have either excellent, good, or moderately good SAGB indexes. This is really important because if the system is functional and it does, do its job and put in a decent amount of groundwater recharge, it's something that we could look at installing in these other agricultural lands where we could have dual purpose and provide recharge at the same time without interfering with the agriculture above. This will help us achieve sustainability and long-term goals under SGMA. That concludes my presentation. Thank you so much for your time.
Hi, folks. We're still in transition to the next site. At the next site, we'll be hearing about the Sustainable Groundwater Management Act, and we will also be seeing some examples of correctly installed flow meters. So please hang on. We'll have a few more videos for you, and we'll be starting again at approximately 9:35.
Located in the heart of California's San Joaquin Valley, the Wet Center is on a very important mission to grow healthy businesses. Water, Energy, and AgTech Ventures become part of the Wet Center with one clear objective: to develop their innovative ideas into commercially viable products and services. Since 2016, we have supported more than 100 entrepreneurs, resulting in over $130 million in funding raised and 350 jobs created through close to 2,000 hours of coaching and mentoring. The Wet Center's collaborative efforts are focused on identifying problems and finding solutions for some of the world's most pressing challenges. Their successes can reduce the impact on our natural environment, create new jobs, lead to safer living conditions, and help communities become more resilient. Our center includes office space for rent, informal and formal meeting space, and plug-and-play space for companies looking to establish a presence in California's Central Valley. Since 2016, the Wet Center has been building the Blue Tech Valley Innovation Cluster to provide services to water, energy, and ag ventures in 39 of California's 58 counties. The Wet Center is located at California State University, Fresno. This brings an academic component to the experienced, committed, and dedicated team. The San Joaquin Valley attracts entrepreneurs with technologies that address some of the world's most challenging sustainability and resiliency issues. Collaborating with an extensive network of business and technical professionals, Wet Center Ventures have achieved impressive successes.
Hi, folks. This is Charles Hillier again. Looks like the APEP team is just about ready to start broadcasting again. I can see that they're getting their cameras set up at Site 2, where we're going to hear from Sarge Green and from Steve Huth. So as soon as Bill is ready, we will hand it over to him.
The audience going here in place, and then Sarge is going to take over here in a minute. So come on in, guys. And yeah. Okay, so we're here at Site 2, which is next to the East Reservoir that's fed by both Fresno Irrigation District and this summer mostly by our deep wells. And out of that, they pump water to other reservoirs and other spots in the field. So we're going to start out with Sarge Green talking about over here. He's going to talk about what's going on with SGMA to start with. So here's Sarge Green. He's a project director here at CIT. And so he's going to take over and talk about SGMA.
Thanks, Bill. We're both Greens, but we're not related. Good morning, everybody. SGMA, that's an acronym. Water people are as bad as anybody about acronyms. And, you know, it's the Sustainable Groundwater Management Act, right? So we'll go from there. However, I'm going to get a little bit bigger picture of groundwater issues. How many people know that the Supreme Court is hearing a decision on groundwater? You do? Good. Yeah. Mississippi versus Tennessee has been argued in front of the Supreme Court, and we're waiting for a decision. It's the first groundwater case in the United States. The Supreme Court has been the referee on other water decisions as interstate. It's got to be between states. The states can't settle it amongst themselves. When it crosses boundaries, right, it goes to the Supreme Court. So the case has been presented. Mississippi alleged that Tennessee was violating their sovereignty. And what that means is that Mississippi is claiming a boundary in the groundwater basin underneath the state of Mississippi, and that Tennessee is violating that boundary by extracting water on their side. It's a large aquifer system, one of the bigger ones in the country. It serves like 7 states. It's and the unit that they're talking about is the Claiborne Sand. And what happened is the city of Memphis and Memphis Gas and Light were actually the original people who were doing the extraction to serve the drinking water needs of the city of Memphis and its environs. And Mississippi's taken issue with that. The argument, though, before the Supreme Court is one that doesn't have much weight with either this Justice Department, any of the so-called other third parties, and or the special master that was hired. A lot of times when you have a very complicated technical case, the court has the opportunity to use somebody who's got some experience in the matter. All of them have said that Mississippi's wrong. They're not wrong totally. And the Supreme Court, in its preliminary analysis, in other words, the questions that they had during the presentations by the parties. The justices seemed skeptical of Mississippi's claims, but they also displayed considerable concern about the potential breadth of the equitable apportionment doctrine and the court's potential increasing involvement in future interstate disputes over natural resources. However, we in California are very comfortable with and understand equitable apportionment. It's what we use here. It's fair share. It's also called the correlative right. And actually, that's probably going to be the decision. But the way it'll come back around to the Supreme Court is that there'll then have to be a factual case about whether or not, under the doctrine of equitable apportionment or fair share of the groundwater, whether Tennessee's extractions are unreasonable. That will be the actual technical aspects of the case. So it's not just California then that is in dire straits. I've got another one. I'm going to read it to you real quick here. Studies and associated projections are showing that many of the state's confined aquifers are approaching, have reached, or have exceeded sustainable levels of use. Evidence of rapidly or continually diminishing water levels, increased chloride and sodium concentrations, and increased recharge being induced from other vulnerable water table aquifers have given cause for concern over continuing to rely on confined aquifers for future supplies. Anybody have a guess as to where that might be? Anybody? Where? New Jersey. All the way into one of the mid-Atlantic states. They have a large sand coastal aquifer system in the southern 2/3 of the state, and they've been over extracting. So they're going to have to go into some type of an allocation strategy either. So over extraction seems to be a fairly common thing going on. What you're talking about is the Ogallala, and actually Nebraska is in better shape than all the other states in the Ogallala. Colorado's not too bad, but Texas, I think, you know, they've already abandoned some farming in Texas because they cannot extract any more groundwater from that particular formation. So, so that's kind of an overview of some of the issues that we're not the only ones facing. So what are the other things that are going on with GSPs? You may know that the GSPs, the SGMA activities, GSPs have been submitted, the Groundwater Sustainability Plans, another acronym. Many of the reviews are still pending, but 4 came out. Have any of you heard about those 4 that were reviewed and got letters from DWR? Yeah. The 2 passed and 2 failed. The 2 that passed were the Santa Cruz Mid-County Basin, which covers a portion of the berry growing area over there, right? So it covers agriculture. That's a good win. The second one that was okay was the 18400 foot aquifer subbasin in the Salinas Basin. Another good win because there's a lot of vegetable growing in the lower end of the Salinas River Basin, right down in there. So they're in good shape. The 2 that failed, Paso Robles and the Cuyama Basin. Paso Robles is our wine growing area over there. They're in trouble. They failed. The other one, Cuyama, is a basin, you know, where Highway 166 goes from Taft over to the coast to Santa Barbara. You get passed through the Cuyama Basin over there. It's a kind of an isolated basin. And I heard from somebody who attended the first session, they have, as a result of the letter, they have started adjudication. So that's the 3rd one that I know of that started since the GSPs were submitted. The other 2 were the basins over in Ventura County, and then the one all the way to Borrego Springs down in San Diego County. So 3 have switched from GSPs to go into adjudication. Then one of the things that we have completed recently here that might be of interest to you is we're going to be releasing a report hopefully in the next month where we did a background and summary on all of the GSAs formed and their organizational processes, all 21 of the critically overdrafted basins. So it's kind of a historical context of what they did, how they did it, and how they got their start. So it sets kind of a background of where we started, and then we can weigh and look and see where we got later on. Some of them, I think, like the 3 I just mentioned, have already switched over to adjudication. So we know there's going to be changes in the future, but we know how they all formed originally. Another effort that we're currently involved in is during the last drought, there was a lot of confusion about how to address certain aspects of the impacts of the drought. And one was dry wells. There was an uncoordinated effort. Office of Emergency Services was involved, California Department of Water Resources, State Water Resources Control Board. And this go around, this latest drought we're in right now, the State Water Resources Control Board ended up with the lead, and they said, we don't want to have that happen. So they asked the California Partnership for the San Joaquin Valley to come up with a coordination process for the 8 San Joaquin Valley counties. Have any of you heard of the California Partnership for the San Joaquin Valley? Yeah, it's an organization that's made up of boards of supervisors, city council members, the private side, but importantly, representatives from some of the key organizations in the state government, Secretary Ross of CDFA, Didi Diadamo from State Water Resources Control Board, State Department of Health. They all have to have representatives. And the goal is to improve the quality of life in the San Joaquin Valley, and water is the #1 issue in that group. So what we ended up with is we've reformed a water work group that's head up by a board of supervisor of one of the 8 counties. And we developed a common communications and outreach plan for all 8 counties. We developed then subgroups to look on permitting, to get permitting done quicker. And we're looking at the data stream to make sure that everybody gets the data. It's good data, whether the state gets it, the county gets it, or even a driller gets it. Because I can tell you what's happened this year, because we're also tracking with our partner. Self-Help is the organization that is responsible for addressing the dry wells. And this year they have recorded up to this point over 700 dry wells. We're talking domestic wells, the shallowest wells. And the reason why we wanted to make sure and coordinate it with especially the GSAs is that a lot of times a homeowner in a rural area that has a domestic well will only drill as deep as the next level that they can keep the pump wet, right? And that could be in another few years dry again. And then what we do is we let the GSAs know, and the GSAs are then talking to the county about making sure that the well gets drilled down to somewhere near the minimum threshold objective, which is the deepest zone that GSAs in their GSPs will have to, will allow water to go before then they shut off everybody if it gets too deep, right? So that way these wells are protected, and then the Self-Help gets grants, and then we're going to be drilling the replacement wells at some level then that the well will last a little bit longer. So that's kind of a implementation thing that we're involved in right now under SGMA. Well, construction standards are under review. What are those are to protect water quality, and a lot of shallow wells or wells that are improperly constructed can have impacts by either leaks from underground tanks. If the well isn't constructed with a seal, concrete seal and a cap and all kinds of things that need to protect water quality, it can be a real problem. And so the state is reviewing those standards, and the interaction that we have is one of the things that we'd like to do is to see if some of the wells that are going to be replaced could act as monitoring wells. So there's a little argument right now with the state of how to figure out how to maintain some of those wells if the GSA feels it has a lot of value in the data gathering business for understanding what's going on, especially in the shallow zones. You know, we have a lot of areas through the Irrigated Lands Program that are going to be regulated for nitrates, right? As well as the CV salts goals. So a lot going on in the business of regulations. The other one is, you may have heard about, is the possible urban model water efficient landscape ordinances under review. And they're probably going to be tightening down on that one as well. So a lot going on related to water conservation and groundwater. Another big thing that is going on as a result of this work also with what partnership is, a lot of water data portals are being redone by the state as well as by the GSAs. They're developing their own data management systems. There's a real good one down in Kern County that we've been looking at. The data management is designed down there to help the farmer understand where he is, what he's doing with in terms of groundwater levels, and so he feels some comfort in what's going on with the conditions. And that also is linked to an accounting system so that they also know where they are in terms of how much they pumped or how much they've used. And that then assists with groundwater markets and trading programs. And let me tell you, That's a really big deal these days. So the groundwater portals then the state is doing, one of the problems we've already seen is the Water Resources Control Board has the GAMMA program, the water quality data. DWR has water quality data in their system they're trying to capture. And we've got them all talking to each other so that the portals are complementary to each other and not competing for resources or dividing the information up in a way that is difficult for people to find it. And there's an overall effort in California called the Open Data Transparency Act, AB 1755, where the state is going to make a lot of more data on water in open portals for everybody to use. So a lot going on then in the data management and data visualization business. Getting back to some of the tools though that we're using to help, especially with trading, for example, is Tulare ID has purchased an EM unit that's farm ready. You know what I'm talking about, where we're trying to figure out the best places to do recharge, and they've been flying that helicopter around, and what it does is it looks at the solids down underneath the ground, see where the open places are, so that you can match the soils with the subsurface and get the optimum amount of water into the ground. And the Tulare ID unit is a portable unit that a farm can use to figure out whether or not they've got some avenues on their ranch. If they got sandy soils on the surface, how will it affect groundwater recharge? So that's pretty cool. I mentioned the Kern data portal. That's the Kern Groundwater Authority, and it will be then linked to the groundwater trading market. And I'll bring that up because one of the things I'd like to point out is, well, if you fallow a field and you know what you were going to plant in the field, you know the ET, you know your allocation from the GSA that you've been kind of delegated based on the native groundwater available, you can pretty much tell somebody this is how much water I can put into the water market. But if you're somebody who's got a crop that all of a sudden the market crashed and you're going to cut the field in half, and you say, oh, I'm going to save 100 acre feet of water by not doing this, I'm going to put it in the trading market, that's a little more suspect. And I believe that measurement in that case requires measuring at the well. So you know exactly how much water you use. So you're much more confident about how much you're going to use to finish the crop and how much can go into that trading market. So the whole business of markets is opening up a real information box that we have to check all the boxes to make sure that we're doing it right, that we can trust that the information is available and how much water there is for trading. One of the new tools to help out with all of that is it just opened up this past week is OpenET. I know a lot of people have using primarily proprietary type systems. There's a lot of people out there with the ET data for the crop types and helping farmers out with understanding both their irrigation scheduling, but then also helping the GSA understand water balances. But OpenET is like that. It's open and it's west-wide, and it's opennetdata.org, and only one N. So there's a new tool out there, and that's once again going to help out with water balances and understanding. But like I said, I still believe that the best tool is going to be direct measurement. And so I'm going to stop for questions here now, and then I'm going to turn it over to Steve. Questions? How mature are the trading markets for water? Some of them are better than others and quite advanced. And I gave a couple of examples. I think the McMullen area GSA has got a pretty robust system already. Of course, they also have Don Cameron's farmland recharge project, and they're expanding that. And they're opening a water bank as well, and they're building a new delivery system out there. So the other one that I'm familiar with is Tule Basin. And the reason I am is because I'm on the board of Tule Basin Water and Land Conservation Trust. And the trust is taking over some land that was purchased to be fallowed completely. In fact, it's going to be turned into upland habitat. And the allocation of groundwater is going to be paid for by the other groundwater users. It goes back into the account for them, and we will not extract any groundwater from that land. They also have a transitional process down in the Tule Basin. That's the basin, by the way, that had the impact on the Frank Kern Canal with the subsidence causing the reduction in delivery capability. So that one is quite advanced. There are probably a few others that I'm not familiar with, but those are the ones that I know about that are pretty advanced. And Geosyntek, I think, is doing the one out there in McMullen. So if you need to contact either Matt or somebody from Sentek to find out what's going on there. Question. Korea as well? Okay. Yeah, Fox Canyon is the one that everybody looks to because was a Cal Lutheran guy that helped put that together. Yeah, I've met him. So that one's been around for some time, but here in the Valley is where we're talking about, right? So yeah, and so is it Greater Kauai? Is it Eric Osterling or is it all three? Okay, yeah. East Kauai, Mid Kauai, and Greater Kauai, right? Got it. Any other questions? You know, that's real. Yeah, he's asking about the market price for water. That's a real interesting one because, you know, there was a trading platform opened up in the Chicago Board of Trade on California water supplies. And I don't know where it is, but I think it's based mostly on surface water availability. So the price was pretty high, I'm sure, last year. I don't know how many takers there were for whatever made it onto the trade center, but groundwater, no, I have no idea because they're going to be probably internal. It could be between buyer and seller, and the GSA is only the grand broker in terms of the paperwork. So I know that happened in previous droughts where farmers were working with farmers. I had that happen to me when I was managing an irrigation district. So all I got was the transfer paper that came through that from one farm to another farm in another district. Didn't see what happened in the transaction. So it's a tough question. Anybody else?
Sarge, is somebody repeating a question to you?
Yep.
Go ahead.
Okay, there was a comment from the audience that said that in the Kauai Basin, it's going to be very restrictive about who can trade groundwater. It's not going to be across any major boundaries. It's going to be rather close to each other. So you're not moving water long distances, either physically or metaphysically, right? Okay, question then.
So you have one
Dr.
question.
Hillier go ahead.
You have one question online from Mohammed, and he is asking any groundwater abstraction quotas in California regulation?
No, it's up to the GSAs to establish. The law says that they have to establish thresholds and they can't exceed those thresholds because then they'd be in violation of the law of causing unreasonable impacts to people. But no, it's going to still be up to the GSP wording and then the implementation strategies of the GSAs.
And Mohammed had a follow-up question asking how it would be monitored.
Yeah. Well, that's why I brought up the notion of measurement. Right now, a lot of them are using ET models to develop the water balances of how much been used. And then they have allocation strategies based on native groundwater over X number of years of calculated natural flow. So they've got two ends of the equation, but I'm not so sure that all of the agencies, all the GSAs have that third leg answered yet as to confirming the validity of any trade amount.
Thank you.
Yes. Okay, everybody, thank you very much.
Thank you, Sarge. That was very interesting. A lot of regulations we're going to have to deal with as farmers and working here in California. Next is Steve Huth from Technoflo. He's going to talk specifically about flow measurement and his meters. He has 3 different meters here, and so we may not even have this audience come around and take a look at stuff while he's talking, but I'll leave that up to Steve, and I'll wipe this down and give it to Steve.
Thanks, Bill. Hey, welcome everybody. Appreciate you coming out. What a wonderful day we have to be at Fresno State. So yeah, Sarge, it'll be floating around later at the trade show. So if other questions come up, look him up. Wealth of knowledge, and I guess what I said earlier, common sense knowledge, which is somewhat lacking sometimes with all the things we have. So great job, Sarge. So flow measurement. One of the things that we're all being asked to do, and many of us have done it, many of us are familiar with it. Biggest key though, with water becoming more expensive as we're buying water, as we're selling water, trading water, recharging the water, putting it back in, taking it out, it's much more critical to get accurate measurement. If we can't measure it, we can't manage it. So I know there's a lot of different good estimating tools with ET, with some of the satellite, but the only true way to be able to get a overtime accurate measurement is using a totalizing type flow meter. So there's a lot of different types being used out there. Many of you are probably familiar with some of the mechanical types. The propeller meter has been around since the 1920s. After that, you know, there was a kind of slight evolution of it, a small paddle wheel. Has a little paddle wheel that turns in the water and measures it. From there was some development of the ultrasonic style meter. Most of those clamp on to the outside of the pipe. And then, like we see here pictured next to me, is a flange style full bore electromagnetic meter. This and some of the later iterations of it are a no moving part meter. Certainly gives us very accurate measurement and has a lot of benefits. Probably the latest thing that we're seeing is the insertion style mag meter, which is back to kind of the style of the clamp on saddle type propeller meter, but it has no moving parts in it. So what's the accuracy of these meters? Well, some of them can be as good as plus or minus 0.5%, clear up to plus or minus 2%, depending on the type of the meter and obviously how it's installed. If we don't have a proper installation, you're not going to get accurate measurement. So for instance, a insertion propeller meter or insertion paddle wheel meter is going to be about plus or minus 2% of actual flow. So let's take a 10-inch meter running at 1,000 gallons a minute. That could be plus or minus 20 gallons. If we take a propeller meter running at 100 gallons a minute, that'd be plus or minus 2 gallons. So you can see that can add up over time. When we get into the full bore mag meters, they can be plus or minus 1% or better. So you double your accuracy by going to some of the later technology meters that are available out there. So Sarge talked about Sigma, but there are some of the districts that fall under the SB 88, which is a Surface Water Act, and the SBX 7-7, which deals with some of the irrigation districts which deliver water to a lot of you out there. These guys all have slightly different requirements. They vary by which law it is, and they sometimes vary by how they're administered in the area. But in most cases, they're plus or minus 5%. So as you can see, all the meters that we are talking about, the propeller, the insertion electromagnetic, the flange magnetic, all fall within those guidelines. And all of these are commercially available and easy to install and easy to manage. So let's talk about the installations now. You know, proper installation is key to getting reliable, accurate measurement. Many of the meters are either district or dealer installed, and most, if not all of these guys are very well trained on the proper installation of these meters and getting the amount of straight pipe. That's kind of the key element for any of the flow measurement, is to get a well-developed laminar flow coming into it. So different types of meters require more or less unobstructed straight pipe in front of the meter. Typically pipe diameters before and pipe diameters after the meter. A lot of times you see this in the spec sheets as D. So like 5D/2D. So that'd be 5 diameters before the meter and 2 diameters after. So the common meters that we see out there is, let's start with the paddle wheel. That particular unit is probably going to need 10 diameters in front of it to get accurate measurement. As we move into the propeller style meters that were typically the most common out there, those also require 10 diameters, unless you've gone to adding the use of a mechanical device called a straightening vane. This could be 3 separate flow straightening vanes. It could be a unit of 6 vanes, or it could be possibly a inverted V shape that inserts right in front of the meter. And what this does is straightens the flow coming into the meter that allows you to reduce that pipe diameters from 10 down to 5 diameters. So shortens it up. When we get into the ultrasonic meters, some of those take 20 diameters. So although they're a no moving part exterior clamp on, they need an awful lot of straight pipe that frankly, sometimes we just don't have the real estate to put in. Hence comes the flanged full bore mag meter. When we get into that style meter, which is like the unit here, has a flange spool, inserts into the line, those will require 2 to 3 diameters. So that dramatically cuts the amount of straight pipe. The other big advantage of some of the full bore mag meters is a much wider flow range. So they're going to pick up lower flow velocities and higher flow velocities than what we see with some of the mechanical meters out there. So as we're managing our water in different irrigation cycles, doing different sets, maybe our flow volume or flow rate might drop down below the minimum flow of some of the mechanical meters, where the mag meter will pick that up. Probably the last one is the insertion style mag meter, which again, as I mentioned, kind of looks like maybe a bolt right into where a prop meter or a mechanical paddle wheel or something like that, and which they will do. Those typically do require 5 diameters, but don't want vanes. Most of those, the vane becomes an obstruction rather than a flow straightener for the mag. So what are some of the flow disturbances we talked about? If we can maybe pan around here to the other side, this is a pump discharge. So on a pump, we've got a 90-degree elbow coming out of the pump, which is a slight flow disturbance. We then have a check valve. So this is to keep the water from flowing back down the well. So there is a flapper in here. As the water comes up, it'll flap up, and as the water drops off, comes down. That flap is going to drive the water down and kind of get a little bounce. So this needs a little bit more straight pipe than just the pump discharge. In this particular setup, it looks like we've got, so this is a 12-inch meter, and looks like we've got probably 5 to 6 feet of straight pipe in front of it. So that would be 5 to 6 diameters, which is more than enough to, this meter only requires 2 diameters from an elbow, but because of the check valve, we've now have 2 disturbances, so they put 5 diameters in there. Through the meter it comes, and then you can see after the meter, we have a good 2.5 diameters before we've created a camelback or a hump to force the pipe to be full. All of the flow meters that we are talking about require a full pipe of water to get accurate measurement. And then this one is nicely done, has an air vent to release any air that gets trapped in the line. And then it drops down and goes into, a pipeline or into the reservoir. So this is a very, very good setup to get accurate measurement with this meter. One of the big things, are valving. If you have a butterfly valve, you have a gate valve, and you're using that for throttling of the flow rate, that should be done after the meter rather than before the meter. If you're familiar with a butterfly valve, it's a vane. When it's closed, it's this way. When it's open, it's this way. Well, that splits your flow in half, and it's just like kind of putting your thumb over a hose nozzle and spraying it out. just really accelerates the flow, but it's doing it down the outside of the pipe. So you need a little bit more straight pipe from a throttling valve, typically 5 or more in there. Many times we get a system installed. We find that the water quality isn't what we had hoped coming out of the well, or over time, as we're dragging water up deeper, as Sarge mentioned, the water quality goes down and we have to do something to it. Maybe treat it with acid. We need to add some chemicals to it for the crops we're growing, or fertigation, which is a way to fertilize the crops, can be done through injecting in the water. All these types of injections need to be done after the meter. On the mechanical meters, injecting it in front of the meter can actually physically damage the meter. On the no moving part meters, it messes with the conductivity and the flow stream, makes it very inconsistent. Be just like injecting air in the line. You're displacing water with something other than water. So a lot of times a meter will be installed, it'll be working fine, and a year or two later, all of a sudden the meters start acting up. Well, lo and behold, the dealers installed the meter, it's all properly done, but a third party comes in, your chemical company or your fertilizer company, and the guy comes out and it's like, oh, hey, if I put my tank here, I only got to run my line 3 feet, and wow, that's right in front of the meter, but oh, no worries. Well, it is a problem. Move it after the meter and all problems go away. So just kind of a thing to point out, because all these things can certainly affect the accuracy of the meter. And that's kind of the key element, you know, with water in some areas, you know, $1,000 an acre foot. We're not talking, you know, pocket change anymore. It's kind of a major issue. So maybe if we can follow over here while we're talking about it, there is another installation, and we'll get to say hi to all our participants here. Wave to the virtual audience, everybody. So over here, kind of on the ground, is a 4-inch meter. And we can see that this one has tremendous straight pipe. So a 4-inch meter would typically only need, you know, 8 inches to 40 inches in front of it. And you can see this one has a tremendous amount more. And the reason of that is we've got several flow disturbances. First, we have a filter set here. That's kind of churning up the water as it's filtering it, dumps it out the side into an 8-inch header across the bottom here. Then we have a 8-inch 90-degree elbow that goes down, and then a second 90-degree elbow out of plane. So it changes direction. So what this is going to do is get that water wanting to swirl. So you're going to need a lot more straight pipe for that flow to straighten out. Thirdly, you can see coming out of this elbow, or it actually looks like a T, is a 8-inch to 4-inch, or maybe that's 6-inch pipe. But either way, we're doing a reduction. And this isn't a smooth reduction with a concentric reducer. It's a, you know, abrupt change from 8-inch to 4-inch. But this is a properly done install, has more than enough straight pipe to get an accurate laminar flow at the metering point. Right after the meter, if we can pan over, you can see that there is a insertion probe in here. This is not injection. I'm guessing this is some sort of a pressure sensor. But rather than messing up that straight run of pipe that they had, they put it after the meter. Perfect install. So key element to having it. So we'll walk back over, and so they don't have to look into the sun here, and we'll jump back. So many of the older mechanical meters that are out there, how do we read them? We go out, get out of our truck, go open the lid, and we look at the mechanical odometer, similar to that on your car speedometer and an odometer. You see what it has, you write it down, and then you do something with it. With a lot of the electronic meters that are out there now, they come with an output, pulse output or Modbus or 4 to 20 or just different things. Most common is pulse. And this data can be collected remotely through some sort of telemetry, through satellite, through cell service. and go to a dashboard and you can download that data. Sigma requires, and it depends on the area you're in, if it's the district or if it's you that has to report the usage on Sigma. Might be you reporting the usage to the district that then rolls that up in your GSA to get there. So it's certainly a huge benefit if that data can be collected remotely and automatically. In the case of this particular meter here, I'll just kind of back up. There is an output port on it that also has a built-in data logger. So in addition to the pulse output that can go into telemetry, you can also plug into this style of meter, and many brands have them. And then you can download the data into some sort of database or Excel spreadsheet or things like that. That's not to say that the older meters can't be upgraded to an output. That doesn't mean that the older meters can't be upgraded to some sort of electronic register. However, typically the cost of that, and you still have a less accurate style of meter, is not the most economical way to do it, I guess. So the new meters have a lot of great things there. So we've kind of all got in this boat together. We got out of this boat back in the 60s after we got into it in the 40s with taking too much groundwater. Now we're back in the same boat we were all in, pulling too much water out of the ground. You know, we all know there's only a finite amount of water on Earth. It's the same water that's always been here. We kind of recycle it through evaporation, through going into the ground, the rain, the snow comes down, goes back up. There's never going to be any more water on this earth. Now, maybe we can desalinate some of it. Maybe we can reuse some of it. Maybe we can clean it up. Problem is, we have a lot more people on earth using more water. So although we have the same water there, we just got to use it smarter. We got to use it more accurately. And certainly the accurate flow measurement with the technologies that are out there is a way to do it. So I think I'm down to a couple minutes here before you guys get to go to the next site. Do we have any questions? Come on, I couldn't have explained it that well. Yes. Right. So the question is, can you just take the water straight how it's brought here and put it to the crop, or does it have to be filtered? That depends on a lot of things. First off is the delivery system. So as water gets more minerals in it, calcium, iron, different things, and you try to apply that through a drip system, which is, you know, the small plastic line with the little spray emitters, it probably does have to be filtered, not necessarily for the crop, but for the irrigation system to get it on there. You know, I'd mentioned fertigation, chemigation, different things like that. Sometimes the water doesn't have enough nutrients or some of the right things in it for the crop, and that can certainly be added to it. A lot of times it's, you know, again, the delivery system, and we get that well blended, they're going to filter it. Yes, sir. Okay, so question was, there's many people that are hiring other people to go out and read their meters or manage the meters, and why are flow meters not being more adopted? So certainly as the regulations with Sigma, the GSAs and things are coming in, I think you're going to find people will be reading meters that they haven't been reading out there, and it's going to tie into it. I'm also, you know, the huge trend is telemetry. There's quite a few telemetry vendors here. We've got a fine one with us on your tour here, Morning Highland. And that's kind of going to, and it's not that you're not using a third party or somebody that you're paying to do it. You're not having somebody that has to jump in the truck, run out there and read it, but they will collect that data for you, post it on your proprietary dashboard that you or your customers have access to. So I think the automation is going to get the access to the data more than it previously did, where you had people that would occasionally go read them. Did that kind of answer the question? Okay.
I've got a question from the online audience, if you're ready for it.
Go ahead.
Okay, the question is from William Bennett. He's asking, what is the best meter for wastewater for irrigation applications?
Great question. What's the best wastewater meter? So wastewater, depending on what it is, if it's, I mean, most wastewater is pretty darn clean water anymore, almost just looks like canal water, other than maybe it's not as clean. But in some cases where there's dairy waste lagoon, there may be solids, there may be strings in it. The best meter for that is going to be a full bore style flange meter, because there's absolutely nothing on the inside of that meter. So anything that goes through it isn't going to get hung up on a propeller or on a probe or a wand or something or other like that. And a lot of times the wastewater applications have lower velocities. So again, the full bore mag meter is going to be a great choice because it'll pick up the lower flows. Yes, one from here. So the question is, have we seen any meters that are used on the individual drip lines? So there are a lot of smaller style meters out there. There's mechanical style ones, there's ultrasonic ones, there's mag ones. Typically the electronic ones will pick up the low flows well. They have batteries in them. So now you're putting them in a drip line and, you know, laying on the ground. It certainly can be done, but it's probably not done much just because it's cost prohibitive, where you've got, you know, $200 to $800 per a small size meter to pick up those accurate flows. And now you got 100 drip lines, gets to be an expensive project. There are some things that are out there that are addressing that, but it has not been really commercially done. For the small 1 inch, ½ inch style meters. I mean, you might be able to get some mechanical ones down in a couple $100 range, but now you're back to mechanical and you got 100 meters. That's a lot of them to read. All right, I think we've got them almost lulled to sleep so they can go back on the bus. Okay, Bill, yes, sir. Well, maybe we'll both answer it. So first one is, you know, how do you monitor different sources? The question was, we have reservoir water, irrigation district water, and pumped water. And you want to keep it separate. So most of the time that's done with different flow meters through the piping. Now it might be the same pipe and one line shoots this way for the well water, one line comes this way for the reservoir water, and another one for it. So typically to multiple sources, they're putting multiple meters in. Semi-tropic water storage district has that, where some sites they have 5 meters. That, yeah. Yeah, either going into one source. And keep in mind that a lot of times meters are pumping into the ground and pumping out of the ground. So in the case of the newer technology, electromagnetic meters, they are actually a bidirectional or forward and reverse flow meter, have multiple totalizers. So in that case, you kind of have 2 meters in one that you could pump into the ground and you get one reading, pump back out of the ground and get another reading, and you would have 2 separate totalizer readings to accomplish that. And many of the irrigation districts are doing that on their turnouts. They're switching from the mechanical style meter that won't do that and go to the electromagnetic, because you can get both forward and reverse flow and use one line without repiping and accomplish two deals.
Thank you, Steve and Sarge. That was very informative. Again, there's a lot of things coming down the pike here the next few years, and having flow measurement is going to be a key item. And that's why Steve and Sarge talked about it, but it's going to be crucial that everybody adheres to those regulations, and you can't do it unless you have information. One of the complaints I've gotten from farmers over the years is, I don't want to measure my water because I don't want anybody else knowing how much I'm using, extracting. And that's something a lot of people have said. Sorry, it's not your water, it's all of our water. And as a farmer myself, I want to be as efficient as possible, and I can only do that if I know how much I'm pumping. So we got to have measurement. And so I think that ties it together a little bit. We're going to take another break here in a few minutes and load the buses. It's going to be about 15 minutes before we get to the next site, probably, because I know the other sites are running a little behind us. But if there's no more questions from Charles or anybody in the audience, we're, I guess.
Bill, there is actually somebody who has their hand raised, George Bush. George, would you like to ask a question directly to Bill or any of the speakers? Looks like George just lowered his hand, so I'm gonna take.
Does he want to ask anyone in chat?
Want to ask?
No.
George, if you'd
I've
like
always
to ask
wanted to talk to a
chat,
president.
go right ahead. Okay, Bill, back to you.
All right. Well, all right. That takes that care of that, I guess. Yes, we do have a question here. I'll hand this to Sarge. That sounds like one for you, Sarge.
No, as a matter of fact, the GSAs are a lot of them are using the ET models for water balance to see where they are in terms of how much they think has been extracted. So it's more of the gross thing. So it's really about the on-farm accounting process and you knowing what's going on for yourself. It's probably more important if you're going to get into the marketing and water trading program, you're probably going to be, but there's no requirement that you actually measure everything on farm right now. But the GSAs are different. Some of them are heading in the direction, like in Madera County, any new well does have to have a meter put on it. So it depends on where you are as the degree that the GSAs and the implementation that they're involved in requires or doesn't require meters.
I've got one more question from the online audience. So that question is, are there smaller flow meters that can be used to measure water use in vineyard blocks downstream from the pump?
I don't know.
Yeah, we kind of talked about that a little bit. Absolutely. When we get into block measurement, you're now not talking hundreds of meters. You might be talking 5 meters, 10 meters for a block. So absolutely, there's smaller meters, be it, you know, a 2-inch, a 1-inch, even, you know, clear down to a 1/2-inch style line. Depending on how much you want to automate the reading on it will depend on what style meter. But yeah, and we're seeing people in vineyards, in some of the higher cost crops going to block measurement. So, you know, they'll maybe have a master meter that they're, you know, for what they're pulling out of the ground or pumping for their total season, but then they want to break it up by each block. So excellent question.
Thank you.
Okay, so the question is how do I economically justify, the cost of the meter? Well, a lot of it is it's just part of something that you're going to be required to do. As Sarge mentioned, kind of any of the new wells are requiring the flow measurement. It's much easier to use the flow measurement reading to generate sigma data or to generate just the efficiency of your farm. Probably the biggest thing that's been around since meters were invented and needed, or somebody had a need for it, was just to manage how much water. I mean, you can get a pretty good estimate. You guys are all farmers, you're all smart guys, you've been doing it for a long time. But it's kind of like estimating the speed of your car going down the road. I think I'm doing about 60, 65. You jump in a different car or you put a different crop in, and now, well, maybe I am getting, 1,000 gallons a minute. Maybe I'm getting 1,200. That's really not that big a difference. Yeah, well, it's 20% difference. So just being able to better manage the resource that you have, the water that you're using, the water you're buying, or the fact that you're regulated on how much you can use. And hey, do I take out 10 acres or do I take out 8 acres, or can I leave everything in? So, you're just going to have to look at the cost. Meters are relatively inexpensive. Certainly as you get more sophisticated with them and automated with them, and tie it into your pump, tie it into your irrigation controllers, remote read the data, it gets more expensive. But the cost of a meter is really pretty darn cheap for the amount of data that you can get to better manage, the water resources and, get more efficient use of it. So I hope that answered that. Yeah, here you go, Sarge.
I think you got 3 spreadsheets. Energy use. You want to keep an eye on the production of the well, right? It's going to fluctuate during the year, but what if the bowls are starting to go, or you're sanding up a little bit? So you can see that by the reaction in the flow meter. Second is distribution. Where's the water going? How much am I totally using? And probably the third is crop productivity. What am I getting out of the unit of water? Where am I missing opportunities to gain income on it? So meters give you those 3 spreadsheets at least to tell you where you are in the spectrum and where you need to improve your efficiencies. So I'd say, you've got a lot relying on one little piece of equipment there to be able to succeed. So I think that's the one way to approach it, right?
All right. Thank you so much, guys. We're going to load up on the bus again here. We have to move to the next site, but thank you, Sarge and Steve, for doing such a great job here. And we're going to head to our 3rd site here right now, Charles.
Okay, thank you, Bill. Okay, everybody who's joining us on Zoom, the APEP team is transitioning to site 3, where they will be giving us presentations about soil sensors, irrigation scheduling, along with Dr. Nocco from UC Davis, who will be telling us about stem water potential and other irrigation scheduling tools. They should be at the site at about 10:35. I think I heard Bill mention that some of the buses are running a little bit late, so we might be delayed, but you have about a 15-minute intermission, and we'll be showing you some more videos produced both by students, by the Wet Center, and by CIT during the intermission. So please stay with us, and we'll be going back live at about 10:35. Thank you.
Hi all, and welcome to my video discussing the benefits of becoming a certified B Corporation. My name is Josephine Henderson, and I'm a junior at CSU Fresno. I'm currently majoring in agriculture business and minoring in art. I'm a member of the Delta Gamma sorority, as well as treasurer and senior chair on the FSU Ag Field Day Committee. Upon graduation, I'm interested in starting a career in either sales, marketing, or design. And I felt this research project was a great way to get to know a different sector of the agriculture industry and branch out into a unique potential career field. Upon accepting this research position, sponsored by the Fresno State Agriculture Research Institute, I was tasked with writing a paper analyzing the benefits of becoming a B Corporation certified company. My main goals when completing this paper included: 1, determining if becoming certified is actually beneficial to a company and its employees, and 2, answering the 3 following questions. Does it pay to be B Corp? In other words, is it economically beneficial to become a B Corp company? How does B Corp attract and benefit potential and current employees? And does B Corp motivate companies to keep improving as they grow and change throughout the years? When beginning my research paper, I had only heard about B Corp very briefly. I had to educate myself on what it was all about, and for those of you who may not know exactly what B Corp is, here's some background information. B Corporation began in 2006 when a group of friends quit their jobs and decided to start their own organization. Today, there are over 4,000 companies spanning across 153 various industries in 77 countries across the world who are B Corp certified. They are dedicated to making it easier for mission-driven companies to protect and improve their positive impact over time. B Corporation certification is a third-party certification and is administered by B Lab. Companies interested in becoming certified must pass B Lab's B Impact assessment. This assessment evaluates company-wide impact on workers, community, consumers, and the environment. Once certified, B Corp pushes the goal of companies balancing profit and purpose. Businesses who are B Corporation certified gain trust with consumers due to a stringent verification process, public transparency, and legal accountability held up by B Lab. So now that we know what B Corp is all about, let's dive into the actual benefits a company can gain from becoming certified. First is the economic benefit. Although companies can most likely expect an overall economic benefit as time goes on, investments must be made to reap the benefits of certification. At the start of the certification process, there is a one-time $150 B Impact submission fee. Once certified, there are fees based on the size and complexity of individual businesses. These fees can be seen at the chart on the right and range from $1,000 to over $50,000. Unfortunately, there are no tax benefits to becoming B Corp certified, but the overall purpose of B Corp certainly outweighs this factor in my opinion. Some of these benefits include access to B Corp community data. Through this access, incoming companies are able to learn how different businesses are managing their money. The B Impact assessment helps to identify needless and wasteful spending, and many companies have shared that the vetting process brings to light unnecessary costs and helps companies identify root causes of wasteful spending. Becoming B Corp certified is a draw for consumers, as customers in today's day and age are trending towards environmentally and socially mindful companies. Not only do B Corp companies gain customer attention, but they also gain consumer retention. And consumers tend to keep coming back to sustainably certified companies that have good quality products. According to a study referenced in the research paper, companies who fostered ideals of sustainability saw growth of over 4%, as opposed to a 1% growth in companies who were not sustainably certified. Not only are there economic benefits, but employees are also experiencing company benefits as well. Continuous B Corp assessment evaluates employee satisfaction as well as retention, ensuring that workers are being treated according to B Corp standards. Sustainability companies may seem more appealing to potential workforce due to their positive impact on the community around them. These factors contribute to overall engagement with work, and companies with higher work engagement saw 22% more profitability and 21% more productivity. This leads to overall increased company success. When discussing B Corp certification, one cannot overlook its benefit to company morale. Periodic check-ins allow B Corp to work with companies to create goals that boost positive company-wide mentality and ensure that businesses are always looking to work towards improvement. Some of these goals encompass changes in social responsibility practices, worker security, health, wellness, engagement, and satisfaction. Goals can help companies work on their overall environmental impact and improve customer relationships. Lastly, and maybe most importantly, B Corp will assist in improving a company's mission, ethics, and engagement. While working on this paper, I learned a lot about sustainability certifications as a whole and what they can really do for a company. Many of the articles and research in my paper supports that the idea that B Corp is an attractive option for companies wishing to create a more structured and beneficial business plan. Becoming certified means potentially having the economic upper hand on companies with a conscious customer base. The B certification shows customers that you are committed to employee well-being, and it helps employers attract value-based workers with like-minded ideals. Studies show that companies with forward-moving goals benefit the work environment, are more successful in the long run as overall company morale is higher. So I want to thank you for listening today, and I hope that this information gives you a little bit more insight into the B Corp world and why more and more companies are choosing to become sustainably certified via B Corp. I personally believe that B Corp is a great organization doing great things for our world, and hope that more and more companies choose to do what you have done and pursue certification.
The Valley Ventures Accelerator is a program within the Water, Energy, and Technology Center at Fresno State, where relevant companies engage with our teams, industry leaders, investors, and fellow entrepreneurs in the water, energy, and agricultural technology sectors of California. Fresno State's strong focus on real-world agricultural issues gives ventures the opportunity to test technologies on the university's 1,000-acre farm while working with students, staff, and faculty. As part of the Water, Energy, and Technology Center's ecosystem, Valley Ventures helps companies access fundings, generate revenue, and establish relevance in the industries they serve. The Valley Ventures Accelerator hosted its first cohort in 2017 with 13 companies. The accelerator was launched with the intention of helping ventures raise funds and increase sales. These objectives have been accomplished by creating exposure to successful entrepreneurs, industry experts, and business leaders. The working relationships established by participating ventures with our teams and subject matter experts have been effective as demonstrated by the funding raised and the revenue generated since the accelerator began. Valley Ventures companies have produced positive results. Valley Ventures has accelerated over 50 businesses in commercializing their technologies and developing their businesses in California. Valley Ventures is dedicated to the advancement of water, energy, and agricultural technology companies. If you would like to learn more, visit valleyventures.org.
Hi, folks. We're still showing videos, and the APEP team is still in transition to Site 3. So please hang on, and we'll be starting up in just a few minutes. Okay, it looks like the APEP team is almost ready. I can see their cameras are back on and Bill Green is there conversing with the speakers. At this site, we're going to hear from Dr. Mallika Nocco from UC Davis, as well as the folks from GroGuru, who will be showing us drill and drop probes, and Mallika will be telling us about various irrigation scheduling tools, including stem water potential measurement. Valdemar, can you hear me? You appear to be having a little bit of audio trouble. This is the thing with technology, is that it never works when you really need it to.
Testing 1, 2, 3. Testing. Hear us. Hey, Charles, hear us.
I can hear you, but the audio quality is very poor.
Testing 1, 2, 3. You cannot hear me very well right now. Is that antenna up? No. Antenna's down. Okay. Maybe that's the problem. I'll move that. Now can you hear us okay?
It's a little bit awkward. It sounds like the online audience isn't hearing what's coming from your microphone.
You can hear me. They should be able to hear me, right? Can you hear me, Charles? Testing 1, 2, 3.
I can hear you.
And so the audience ought to hear me the same thing as you. Is it not? It's not coming through good?
What I'm hearing sounds like what I would hear from the speakers, not from your microphone.
Okay, we're gonna work on it here.
Okay, for everybody watching online, they're going to do a little bit of troubleshooting, and we should be back in just a minute.
Testing 1, 2, 3. Can you hear me okay now?
That is fantastic, Bill. Thank you.
All right, good. We're back online here. Sorry, we had a little. All right. Which camera are we using right now? All right. Oh, it's facing. Yeah, you guys got to see Valdemar instead of me. Which is all right. He's got a cool hat though. Anyway, we got a tractor going. That John Deere, we don't want that John Deere making a bunch of noise. Seems like I'm still cutting out. Okay, we're here at site 3 now, which is next to the mature pistachio orchard. We have young pistachios were planted next door, and some other crops around here and nearby. But we got a couple speakers here. Dr. Mallika Nocco from UC Davis is going to be talking about irrigation and water management. And then we have a soil sensor company, GroGuru, will be talking about what they've got here today and showing us with Sentek probes what they're doing with their field stuff. So I'm going to start with Dr. Nocco. I'm going to wipe this down and give it to her, and she's going to take it away.
Sounds good. Hello, everyone. My name is Mallika Nocco, and I'm an assistant professor of cooperative extension out of UC Davis. My specialty is soil plant water relations and irrigation management. I really want to know, first of all, welcome to the irrigation station. And I would love to know like what folks are growing to kind of think about, for all of us, some of our examples and kind of help to contextualize. So who's growing almonds? Anybody? All right, pistachios, olives, grapes, okay. Grapes over there. Any other crops? What have I missed? Cherries and oh, this is vendor. Okay. All right. Vendor. So what are you vending? Water potential sensors. Okay, you're going to get the tough questions. Yeah. A biofertilizer. All right. Okay, so that is actually is helpful. And then for our virtual audience, do we
We seem to have lost audio.
Yeah.
For the folks watching online, I think they're swapping out some batteries, so please stand by.
All right. Oop, going again. Here we go.
So I just want to talk a little bit about the basics of irrigation management and also just think a little bit about decision support systems. So a decision support system for irrigation management is going to provide growers with some sort of data or information from their fields, right? And that the data can take several forms. It can take the form of some sort of soil sensor or soil water potential, soil water content data. The data can also be from the canopy. There can be canopy level data, and there can also be remote sensing data. But what I would love if everyone can kind of remember and think about with a decision support system is that support part of it, right? It's a decision support system. So in a couple of the other stations, some of the folks that asked the sensor folks who are going to talk here, how much will my yield improve if I put the sensor in? Or I've heard before too, like how much will my yield improve if I start doing irrigation scheduling? And that's where that support comes in. Just because you put a sensor in, or just because you start taking a measurement or start to collect some sort of information and integrate a decision support system into your irrigation practice doesn't necessarily mean that decisions are going to change. The decisions are from you, right? So this is about collecting information, interpreting that information, and potentially using it to improve your yields, improving it to conserve water, improving it to, or using it to improve your nitrogen management and your salinity management. In terms of just an overview, thinking about soil specifically, how many folks are familiar with the term field capacity? Most folks are here. Okay, how about available water holding capacity? Plant available water content? Yeah, okay. All right, so I'm gonna do a little analogy for everyone. I like to think of this, the soil as a sponge, and you can do this as a super fun demo, if there's kids in your life or whatever. And take a sponge, put that sponge under a sink and just let a little bit of water run and saturate the sponge. So this would be a saturated soil. If you remove that sponge from the sink and you let it drip, the water that's dripping, that would be gravitational drainage. When all of that water has dripped from the sponge, what's left? What's being held in the sponge is being held by adhesion and cohesion, and it is the same way in a soil. So in a soil, You have adhesion. Oh, nope, not doing it. You have adhesion and cohesion, and that holds those forces hold the water in place, and that is the water that would be available for plants. And that is what we call field capacity of a soil. Now, if you were to take that sponge and think of it as soil and squeeze it as if, you know, you are like very powerful roots and have squeezed all of the water out of it to the point where a root couldn't access any more water, there's still some residual water in that sponge, and there'd still be residual water in the soil. But we call that point permanent wilting point, because even though there may still be water in the soil, that water is no longer accessible to plant roots. And when we take the value, the water content value at field capacity, and subtract the water content value at permanent wilting point, that's the available water for plants, or plant available water is what you hear that called. So if you are going to use a decision support tool that's based on soil, it could be based on soil water potential, which is a way of thinking of the energy with which that soil is holding water, or it could be based on soil water content. And that type of decision support tool, you know, we're going to see some soil probes here. It's going to give you an estimate of what the soil water content is, and in a time series. So there'll be some continuous, very intriguing data that we're going to talk more about. And the way in which you would manage irrigation in response to that would be to manage the available water content for a given plant. And plants have different tolerances and different values with which you can go down to an appropriate available water content. I know that there's somebody who is growing wine grapes, and they can actually handle quite a bit of stress, right? So if you were to manage based on soil, you could really actually push that value down pretty low, depending on the time of year, depending on the moment in the growing season. So similarly, another type of decision support that I would like to talk about are canopy-based tools, or thinking about the leaf. So one example of that, I'm not going to do the measurement, is over here. Does anyone know what this is? We have two. I would like, oh, no, I'm not going to call on you. Yes, over here. Pressure bombs can be used to take a measurement that we call stem water potential. So remember when I said soil water potential? Soil water potential is kind of the energy of the water that's being held in the soil. The stem water potential is kind of give you an estimate of the plant's stress level, and you'd use a leaf, and you take the measurement in the afternoon, so sometime between 1 to 4 p.m. But there are units available that you can that are standing units that you can actually pump, and you don't have to worry about dealing with this. Basically, use the gas push or your you know, foot the what? Oh, to actually look at what the stem water potential would be of a given leaf, and then you can find it very easily. So that also several canopy-based decision support tools. Can include, you know, something that's going to do optical sensing. So does anybody know, for example, what NDVI is? Is that something people have heard of? A few. So there are different ways and different reflectances that you can use to get an understanding for where the canopy is with its development. And some of those can even be used to calculate what we call a crop coefficient. Has anybody heard of crop coefficients for irrigation management? Oh, we're switching my microphone. Technical difficulties. How is this? Is this better? I don't know. Okay, closer. Okay, this is good. I know. This is the coolest I felt in a long time. Okay, so much better than Zoom. No offense. Sorry. Okay, so in terms of I'm going to actually talk a little softer now. In terms of the canopy types of measurements, so there can be these optical measurements, and they can give you some sense of the phenology of plants. A couple folks did raise their hands and say they were familiar with crop coefficients, but I'm going to give a little bit of an overview for others. In California, we have something wonderful called the California Irrigation Management Information System, and it's a series of meteorological stations for irrigation management, hundreds of them throughout this state. And each of these stations are standardized with equipment to measure, air temperature, humidity, solar radiation, and wind speed. And these together form an index of the evaporative demand of the environment for a hypothetical crop, like a hypothetical well-watered alfalfa reference. And this is called the reference evapotranspiration. So the reference evapotranspiration does not tell you anything about your crop in that moment. It tells you something about the environmental demand for water. And if you use that and you multiply it by a crop coefficient for your specific crop and for the specific time of year in its development, you can get an estimate of the maximum, the theoretical demand for water for a given crop on a given day. And this is kind of the basis for many different canopy-based irrigation management tools. There are other actual evapotranspiration tools out there that are going to be measuring the actual evapotranspiration of your canopy as opposed to the theoretical. And these actually would be solving what we call the energy budget and giving you an estimate of something that we call latent heat flux that gets transported or transformed with the magic of physics to an estimate of actual evapotranspiration. And that's a little bit different. That's giving you what your crop is actually using. So these are two other types of decision support tools that are going to help really with that water banking. How much crop did my water use last week, or how much water did my crop use last week? How should I think about how to replace the water that has been lost? That's kind of the nature of those tools. The last category of decision support tools I want to talk about before opening this up for questions a little bit is remote sensing tools. So there's remote sensing and there's proximal sensing. Proximal sensing is just like sensing something kind of close to the ground, like maybe touching it with an instrument. And there's soil mapping proximal sensing tools that are available. So if anyone has heard of like a Veris soil mapper or an EM30, but these tools can be used to develop high resolution soil maps for your fields or for orchards. For an orchard, it's a great idea to do one of these things before you put in a new orchard. It's also a good idea to think about high resolution soil mapping if you have a very variable field and you want to think about where to place your soil moisture probes or soil probes. Additionally, there's remote sensing. So remote sensing can be in the form of drones. It can be in the form of airplanes. It can be in the form of satellites. So if you want to check out my lab, my research, it's called the Conservation Irrigation Lab. Our website's irrigationlab.com. We do a lot with precision irrigation, and I work a lot with drones. But whether you're working with a drone, whether you're working with an airplane, whether you're working with a satellite, the types of imagery that we're using are pretty similar. So we're thinking about reflectances again. And when it comes to crop water stress, we're thinking a lot about thermal imaging and thermal imagery. And I have a question for all of you. If you have a crop, a plant that's well watered and the same type of plant right next to it, and it is water stressed, which one is going to be hotter and which one is going to be colder on the thermal imagery? Any guesses? Yes. It's going to be warmer? Yes, that is correct. And that is because it's going to have lower transpiration, right? And so there's going to be lower evaporative cooling compared to the well-watered plant that's going to have more transpiration and more evaporative cooling. So it's going to be cooler. And that is the underlying theory and principle of all of the decision support tools that are using remote sensing, are using aerial imagery, are using drones to tell you something about crop water stress. It's thinking about that, that relationship. Something that we're working on in the research world is taking those maps, and this is something that I do at a research level, and making them maps of actual evapotranspiration that are very high resolution. Myself and several other scientists are collaborating, and kind of the dream on this front is to have high resolution maps at the scale of like a tree or like an individual vine of evapotranspiration every single day, right? That would be the dream. And I think that that dream is going to be reality. So that kind of is my intro to irrigation, intro to decision support. I'm curious to know if there are any questions. There's a couple minutes. Yes. Yeah, I mean, I think that's a real, but that's very true. Like if, oh, repeat the question. So the question was if, I like how there was the repeat question card. So the question was, you know, some folks are interested in using NDVI for management. And that is only showing you the top of the canopy. So how does that, you know, relate to the rest of the canopy? And I guess not to answer the question with a question, that's like very classic scientist. But I would say it depends on what the goal of management is, right? Like, so what are you thinking about trying to do with it? There are other tools that you could use. And I guess my question would be, are they using it for a crop coefficient? I think if they're using it to think about crop coefficients and the canopy's development from an irrigation management standpoint, that being at the top of the canopy is okay if you're going to be using it to calculate crop coefficients, as many of these tools do. If it's being used to sense something that is happening in lower parts of the canopy, then it's not going to be as good of a tool. But that's a good question. Any other questions? Yeah. That is a great question. So the question is, what is the achievable solution? Oh, resolution. Yeah. So in terms of decision support tools that are available for water management from remote sensing, I am going to think of a couple that just the ones that I'm familiar with. And if others know of others, please let me know. So at the satellite scale, we have 10 meter pixels. And that is coming from, I know Irrigation is a tool that I think it has a 10 meter resolution. And from aerial imagery, so for California, there's a company called Ceres, and they are collecting and providing decision support using aerial imagery, and they have a 1 meter resolution. Or I think it might be even a little bit less than that based on where they're flying and what they're doing. But then the issue, the constant issue with remote sensing is how often are you going to fly, right? So there's a trade-off that exists right now that I think in the near future, we hopefully will be able to overcome that challenge of the trade-off between having high spatial resolution in the imagery and not as frequent of flights, right? Or as frequent of satellite overpasses. And I think folks are using several different kinds of, you know, machine learning algorithms and things to try to resolve what happens between the dates that these images are collected, either at the satellite scale or at the aerial scale. Like I know myself and several other researchers, we have a project with almonds where we wait and then a satellite goes over and we fly a research grade drone, we fly a commercial drone, we collect a bunch of measurements on the ground, we do all this stuff, and we're, you know, basically trying to resolve that issue where we have high resolution imagery on a few dates, and then, you know, we have to try to build in between and think about what would be high resolution evapotranspiration, what would be the differences within a field between the dates that we have imagery for. That's the future. Any other questions? All right, thank you. Oh, yeah, sure. Yeah, no, that's a great question. So I will say that I think you should have a QR code, and the folks who are remote should have access to our handout to show that we're actually doing something of a study similar to the question that you're asking, which he asked a little bit about ROI and price points of these different irrigation decision support systems. Some of that's going to be up to you, right? Getting back to the support part of decision support, and how much money you save, how much money you make is going to be based on how you integrate the actual information and make decisions, right? So if you are going to be making decisions to cut water and still, you know, improve your yield and using these tools in such a fashion, I think you may get a higher ROI than if you just put a sensor in and, you know, don't change anything. But I will say that in the project that we're doing that's funded by the California Energy Commission, One of the goals of that is to do some of these comparisons and to think about different decision support systems and how much money could potentially be saved and how much money could be saved from the energy savings as well of better irrigation management, which is something that I hope everyone is also thinking about, especially after the drought year we just had.
So there's a question from the online audience, if you're ready for it.
Yeah.
Okay, so this question is from Mohammed. His question is this affordable for small farms? And what is the optimum farm size or lot size?
Yeah, this is a great question. I would say that there are some free decision support tools that are available that would be maybe a better choice for a small farm that didn't want to invest in, a larger and more expensive type of decision support. So one that I want to shout out specifically is the University of California Agriculture and Natural Resources program that's called Crop Manage. It was developed by Michael Kahn, and it has I'm not sure exactly the number, but it has all of the top kind of California crops. I think 10 to 15 crops are in it. And it uses basically how much information you have to give it. So you could just run it with agronomic information based on your field, and it will actually bring in the meteorological information, bring in the satellite information, predict using that crop coefficient method I talked about, predict how much water is being used and how much water should be applied. And that would be a free tool. And there's also several trainings available to try to use that tool. One of the things that I have observed and that we are kind of working to think about, I have a new project with Dr. Ruth Dahlquist-Willard, who is the UC A&R Small Farms Advisor, is to think about the satellite tools and how these tools work for fields where you have a variety of different crops and diverse growing practices on the same field. And that is when things get kind of trickier, because if you're talking about that 10-meter resolution that I mentioned, that is like one of the highest satellite tools that are available. But if you have like a 30-meter resolution or higher than that, it may not be as useful for someone who's growing several different crops within a field. And so that would be something kind of to think about for small farmers. And that project that I have that we are just starting is to actually start to think about some of these tools for different types of farmers, for small farmers, for people who are growing diverse crops as well, is an area that we want to make sure that we're not missing. So yeah, I don't know if that was really an answer, but it is something that at least I'm aware of and we need to think about. But Crop Manage might be a place something to try, just if you wanted to try decision support with low risk, because it's free.
Thank you.
Okay, thank you so much.
You guys can use this handheld too if you have to, because it might be better than having to switch it back and forth. You can just do this. So anyway, but you keep it right in front of your mouth when you use it. All right, thank you. We're going to go now to GroGuru. Alex, are you starting off, or and we also have Gill Costa from Sentek, so we'll have both of you guys do the talking here. And I think you're going to move around and want people to follow you around and look at some stuff too, I believe, right? Okay, very good. Let Alex Breckinridge take it away.
Hi, so yeah, my name is Alex Breckinridge. I'm the senior agronomist at GroGuru. And today I am here kind of working with my best good friend, Gill from Sentek. And the reason we're working together is because we do have a decision-making tool that we were just talking about for strategic irrigation management. I am on the software side of things. So what we do at GroGuru is we're able to take the Sentek probe and then translate that data into something actually meaningful and actionable, not only for just the growers, but also the dealers alike. So what we do that's unique compared to others is we'll take a Sentek probe, if you don't mind holding it up there, Gill, and throughout the course of this specific probe, there's 9 individual sensors along it. What we do is we will take the measurement that we get from the probe. And the analogy I use is that it's very much like a Celsius and Fahrenheit. So the probe reads in Celsius on a scale from 0 to 100 of volumetric water. but Celsius doesn't mean much to us here because we're Americans. So we will translate that into Fahrenheit. We take that absolute or Celsius measurement, as I call it, and then translate it into a relative sense where it is much more easy to make a decision off. What's also unique is that we will also take it and we'll do this for each individual sensor alongside of the probe. So if we go back to the analogy of the sponge earlier, we basically put 9 sponges throughout the length of the probe, and we'll measure the field capacity. And we can do that through AI. So that's very scalable for the dealers or the agronomists that are supporting it. And that is very easy to detect. And of course, we can have a manual correction, but we're able to interpolate the data and determine where field capacity is. And then from there, we can use proprietary algorithms and then experience and determine off that what permanent wilting point is. So we get the boundaries for each individual sensor, and then we'll take those and average them together and overlay it on a color-coded template to better visualize where exactly we want to be throughout the growing season. So the template itself is fluid for the crop demand during the time of the year, and then it also runs 365 days a year for certain crops. The idea behind that is it's becoming ever more prevalent, not only to just manage moisture during the growing season, but also in the off season. So for example, this last winter here, we got virtually 0 moisture. And a number of our growers started the season in less than an ideal spot with soil moisture, especially at some of their deeper sensors. So a very common theme on June 1st, we saw the deeper sensors, all of them just nosedive in terms of soil moisture, but we were unable to keep up with it because we weren't starting with a full gas tank. So going forward, the need to put sensors in earlier and then manage 365 days a year is going to become very prominent. Being able to measure that winter moisture. And as we come into January and February and March, if we're not getting the rainfall that we historically were needing, we can now manage that and then pre-irrigate off of that. For those that maybe aren't aware of what we specifically look for in the data, and Gill will talk here in a minute about how we install the probe in the active root zone. But when we do that, we're able to see signatures in the data of the plant drinking during the day and then resting during the night. So it's a stair-step motion until we see an irrigation event, and then we see the increase in moisture on the graph. But what we can also interpolate in the season is by using or by visualizing the length of that stair-step. So if it's a hot, windy, 105-degree day, we're going to see a large amount of soil moisture taken out. If it's a relatively cool 58 cloudy day, we're not going to see a significant amount of moisture taken out. So we can start to depict with better accuracy where exactly we need to keep soil moisture for that time of the year. What we've also incorporated in, not just looking historically and at the current amount of time, but we've partnered with DTN and utilized some of their clear ag crop models along with their weather forecasts to be able to predict out where soil moisture is going to be forecasted out a couple of days, depending on the crop type. So we're giving the full solution, not only looking backwards, but also looking forwards in a super easy, grower-friendly and dealer-friendly user interface. I have worked with the Sentek guys and I've worked against them, and they consistently provide good data day in and day out, but the data is useless if we're not able to translate it into something meaningful. So being able to present that decision-making tool to the grower is critical. Otherwise, the tool is worthless. Probes are not a magical wand. You can't just go put one out, as we were alluding to earlier, very much like you can't just go buy a treadmill and put it in your basement and expect to lose weight. You actually have to utilize it. Yes, I know. But that being said, if you're able to translate the information into something that's literally just pictures and colors, the growers have a much easier understanding of how to use that. Is this all making sense? Any questions thus far?
I have a question online if you're ready for it.
I am.
Okay, this question is, what probes does GroGuru use for all year long data?
Sentek. They work really well. Gill can speak to the advantages of that. I don't want to steal his thunder, but we've buried them 6, 7, 8, probably 10 years. You guys have some. They just work. A lot of times probes in general are damaged when during the install or removal process. But if you're keeping them in the ground, there's a much lower chance of any type of failure. But as I just mentioned, I've worked with the Sentek guys and against them, and it is making my life much easier utilizing the drill and drop. Whether that's a potato crop up in New York, a cotton crop where I'm at, perhaps in Missouri, or almonds or pistachios out here in California.
So there's a follow-up to that question, which is in the same context, is this also true for subsurface installations?
Are we using Sentek probes for subsurface installations?
I believe that's the question, says simply for subsurface installations, and it was from the same person who asked the earlier question.
So yes, we have buried probes. We have a couple of options there, but we can, yeah, we buried them below the soil surface and just ran the cable out. So they do come in different lengths, the Sentex. So whatever your situation is or your crop type, whether it needs to be a 1 foot up to 5 foot, right? I think our most common is just the 3 foot. So 3 foot, 9 sensors. We have the ability to include a salinity measurement. If that's a concern where you are, that can kind of depend on geography. If it's not, we could omit that sensor and go with a less expensive option. But obviously out here in California, specifically speaking, that can be an issue. And that is one thing that we do also perhaps want to track.
And can those probes be buried in the soil for multiple years?
Yes.
Thank you.
Yes. What are the inputs we're collecting? Okay. So the question is, when I say GroGuru is using AI, what exactly does that mean? So we have a couple of different models, one being water percolation. So we're able to visualize through the AI whether a wetting front, it's irrigation or rainfall, how deep that went in the profile. Through the signatures in the data, also the stair stepping, we're able to determine where the active root zone is, so where we're visualizing roots. Whereas historically, that was a manual process. And then the most important and my favorite is the agronomic threshold. So from the indications in a potential sensor, when we see a large increase in soil moisture and then it's steadily dropping, through repeated events, we can gain more confidence exactly where our field capacity is. From that, depending on the crop type, we can then make a highly educated guess what the permanent wilting point is. And through the course of time, we can then use the AI to refine that as well. Wonderful. I am going to now pass it over to my good friend Gill, who's going to talk more about the technical aspects of the probe, and we'll let him have it.
Excellent. Hi, my name is Gill. I work for a company called Sentek Technologies. We manufacture soil moisture probes, and we basically are the leader in the industry in regards to into this technology where we integrate to multiple platforms, being our latest partnership with GroGuru. I just wanted to highlight in regards to what I've been learning throughout the years at Sentek and the mistakes I've seen in regards to installing these probes. First of all, the major mistake that I've seen is when you're installing these probes, you have to install, I might have to put this on my head, I think. Yeah, and I might have to put it on my head. Yeah, perfect. So just going back here, can you hear me now? My head's kind of big. Even closer. There you go, in the mouth, right there. Just going. When you install this probe, you need to be able to slide this auger all the way through into the ground, all the way to the rim. You can see that the auger itself is longer than the probe. And to be sure that we're going to have enough room in the soil, we need to be able to slide this auger all the way through, in and out without turning that drill, so that we're sure the diameter is the same matching as the probe for the undisturbed installed. Remember, we developed the technology based on problems we've seen in data quality, where if you disturb the soil around the probe, you basically have skewed information. So what we developed is an undisturbed installation process where it keeps the integrity of what we're aiming for our measurement, which is the water holding capacity adjacent to the sensors, right? So water holding capacity is the key to crop successes, right? And maintaining field capacity throughout the season. So that's the first point I'd like to make in regards to installation errors I've seen in the fields. The other one is placement of the probes. The probes need to be placed next to the trunk of a tree, next to the root zone of active growing crop, right? There's no point in installing that probe in between the trees. It has to be next to the tree where there is actual active extraction from the roots. So keep in mind those two items when you're installing. You have to slide that auger all the way through and pull it out without turning that drill. And then please install it next to the crop itself so that you can see the water extraction from the crop. So just starting there. And then moving forward in the installation process, where do you make your site selection? First of all, you have to understand what soil type you're working with, right? And then understanding what are the textures of those soils. And further, that would be revealed with the water holding capacity of that soil. In regards to the main line, you want to be 2/3 down the row where you'd have the water availability be more restrictive. So you want to be 2/3 down the row so that there's no loss in yield due to irrigation potential inefficiencies, right? We want to all achieve 100% uniformity, but that's literally impossible, I would say. So just be sure that you're putting it away from the main line to get the most restrictive area. And then a lot of the guys shortcut the installation by not using the tripod. The reason the tripod was developed is you need to keep that soil vertical into the soil, or you need the probe vertical into the soil so that you're getting the real profile movement of water. We're not measuring at one depth. All these sensors will have a sensor spaced every 4 inches along the profile, right? So for example, this probe here will have 9 sensors along the profile, which would mimic any root zone. I think there was a question earlier, what probe would we use? The probe needs to match the root depth of your crop, right? So for example, Northern California, we have a lot of walnuts. The walnut guys are all putting 5-foot probes in. We moved towards into the Midwest. You guys are putting 3-foot probes in corn, right? So you really need to understand, in California, you probably have to understand your root stock. We sell probes into dwarfy root stocks up in Washington. Those guys are putting 2-foot probes. They don't really need to measure more than that. So that's what guides the decision in regards to how long the probe you're going to be installing. Perfect. So now I'm going to move into a few other items that I took some notes on. What questions are the probes answering through a partner like GroGuru as a platform, right? We're answering the question of irrigation frequency. How many times a week am I going to be running the water, right? And the second main question we answer is the duration of that irrigation, right? When let's say we were to be watering these pistachios, and when the probe responds at the deepest level of the sensor, we'd be turning that water off. We don't want to go past the root zone, right? In any instance, you'd be waiting water, fertilizer, and energy all in one. So those are the two main questions: frequency and the duration of the irrigation event. And then with GroGuru has a really good algorithm where the water dynamics in the soil actually reveals where field capacity sits and where onset of stress sits. And there's going to be two major schools in that front. One would be the school that would send your soil sample to the lab, get the analysis from those numbers in regards to particle size distribution to determine where field capacity sits and where wilting point sits. And then further, we'd also be looking at the salinity feature of the probe to be able to keep the fertilizers in the root zone. And then again, going back to infiltration rates and determining your run times to match the root zone of the crop. That's pretty much what we offer as a manufacturer of soil moisture probes. If anybody has any questions, we're ready to answer. Oh yeah, by the way, on my way up here, good call. On my way up here, my favorite podcast is called Growing the Valley, and the researchers were today actually talking about, I just failed installing a probe because this field here is super dry. I don't know how these trees are alive, but I was trying to install a probe over here and I hit rock. And what the first top foot of the probe, if you have water in the next few weeks, should be at field capacity, because if you get a cold event, you're going to kill your trees with frost damage, right? So anybody that's watering, keep that full first foot profile at field capacity for the entire winter, because it's going to be tricky to avoid frost damage. Thanks for reminding me of that. Cool. Anybody have any questions? I guess not. Perfect. Online?
Nothing online yet, but we are standing by.
Yeah, okay. I mean, do you guys want to? Oh, go ahead. Right. I think I'm going to pass you this one.
My head's not quite as big as Gill's. The question was the density, or how many probes to put in a field or a farm, and it's a very subjective type answer. But to keep it simple, you want to have at least 2 probes or 2 sensing locations per irrigation zone. This way, I have one, I have another one. In case something happens to one of the units, a tractor runs it over, or something gets eaten, or you have cracks in the ground, you always have one to compare versus the other one. So we recommend 2 per irrigation zone. You can also look at it, if I'm a tree crop, I want one every 50 to 75 acres. And if I'm under a pivot, I want one every 120 acres, because that's a typical size of a pivot. So that, does that answer the question? Okay, great, thank you.
I got one more point to say.
Uh-oh.
Make it bigger. So yeah, exactly. Just going back to what our partner at UC Davis mentioned earlier, there's a quick math that I do in the beginning of the season. I'm actually a small farmer, just to check, because remember, the longer the probe is in the ground, the better your data is. And the quick math you can do in beginning of any given crop season is basically subtract field capacity minus wilting point. That's your total available water. And then depending on your crop, you're going to have, some people call it manageable allowed depletion. I call it maximum because it's the bottom point where I want to dry my soil. So I call it the maximum allowed depletion in regards to, let's say, almonds. Almonds, I'll let them dry up to 40%. So I'll multiply my total available water times my maximum allowed depletion, and then subtract that from field capacity, and that will be my onset of stress for that crop. And that math can be done in the beginning of the season. Remember, it's the beginning of the season where you don't have any thresholds if you haven't had this probe in the ground long enough to where the algorithm can kick in. So that's the quick and dirty math. And the USDA has a very good tool. It's called the soil water characteristics. You plug in your clay and your sand content in there, and it spits out immediately where your water field capacity is and where your wilting point is. And then from those 2 parameters, you can run the initial thresholds. So just wanted to share that with you guys as a beginning of the season tip. Perfect. Thank you. For 5 minutes. Now, okay. Go ahead. Who's going to answer? Go ahead.
Yeah, some real simple ways of thinking about it. I mean, the question was the ROI, the return on investment for using something like this. So as we had mentioned earlier, putting a probe out in the field is just an irrigation tool. It's kind of like Alex's example of, I can buy a treadmill. If I don't use it, I'm not going to lose weight. So the ROI really depends on how you use the tool that you're given. So the most important thing for any crop, whether it's the grass in your backyard, it's an almond tree, it's corn in the Midwest, it doesn't matter what the crop is. It's putting the right amount of water on at the right time. Because I can have the best land, the best soil, I can buy the most expensive fertilizer, nothing grows without water. So my ROI can be, I can use less water by putting water on at the right amount of time. So a perfect example, we have a lot of vineyard customers here in Central California. The vineyard customers want to pull back the water usage in that March, April timeframe into May. They're pulling it back to keep the canopy from growing too much. If the canopies grow too much, then you can have the grapes can get mold and fungus. They have to go out and cut it. So they want to manage the moisture to keep it back to not grow a canopy. Then they want to hammer those grapes and get the water in there to fill those grapes up at a later date. So that's how you can do your ROI, is just an example of keeping the growth down early and hitting it with the water when I need it. And the only way to know how to do that is you can go walk your field, you can go dig a hole, or you could sit in Cabo while you're having a margarita, and you can look at your water content by using the software and using a probe. So I think that's it. More questions? Not bad, huh? Not bad for an old guy.
The question we need to answer is also, would you drive your car without insurance, right? Because you wouldn't. So the question is, what is your potential maximum yield if 100% of all the metrics that can be managed were achieved, right? And what you're trying to avoid is fighting the variables that would set you back. And knowing your water content is basically avoiding losses, right? So let's say there's a 30% variability per acre, right? What does 30% in yield cost you in almonds today? At $2, let's say you're losing $600. So it's about $1,200 per acre. So 1 acre of your farm would easily pay for a system pretty much, right? So, I mean, we did like we were talking about earlier, we did a quick analysis in regards to the risk of growing potatoes in Idaho, given the variables of the season. It's $1 billion, give and take, right? $1 billion, right? So that's the variability. What is your return on investment? It's very visible, right?
Thank you so much. Thank you, Bill. Thank you to the GroGuru team, and thank you, Dr. Mallika Nocco. She's handing cards up there. Good, appreciate it. I need to get one actually. Anyway, well, thank you, Charles. No questions, right? We're ready to go.
There are no pending questions online.
All right, great. Well, we're going to head back to the trade show then, and we'll have more interviews and stuff going on for the virtual audience, along with the live audience there too. So anyway, thank you all for coming. Thank you. Dr. Nocco came down from UC Davis, and we appreciate her making the trip down here. So thank you so much. And thank you guys. Actually, Alex came from Kentucky, I think. So you came to probably the farthest. Yeah, he even says it right. So anyway, all right, guys, thank you so much. We'll see you back at the trade show in about 15.
Okay, thank you, Bill, and everyone who's joining us online. In a few minutes, the APEP team is going to pull into the CIT testing parking lot and yard, where we have a trade show set up. For those of you who are joining us online, what we're going to do is do some interviews with the booth vendors. So in about 15 minutes, I'm going to join Bill and the APEP crew, and I'll be doing quick interviews with a few of the booth vendors. So you will see me over there with them in a few minutes. In the meantime, we'll have another intermission. We'll be showing you some additional videos. I hope you enjoy those, and I will be seeing you again soon. There's two aspects to this project. One is a physical study about the feasibility of using recycled material, particularly using thin-walled irrigation drip tape that's typically a single-use product, and reprocessing it into thick-walled drip tape, which is a long-term product. We're taking plastic that's already in the irrigation stream and turning it into something that was a single use into a long-term use product. The other aspect of this project is an economic study. And that's where the innovation lies, was that having these recycling operations is inherently limited by distance and limited by the relative price of new resin. The premise is that for recycling to be feasible, there has to be somebody local who knows where their single-use strip tape is being used, it has the resources to go and pick it up, and can transport it back to the production facility where it gets turned into new thick-walled tubing.
Drip irrigation provides incredible and significant benefits for growers around the world, but that drip tape goes to a landfill. Many of those environmental benefits would be offset and negated. So it's really important to me personally, for our company and our management and our staff, to ensure that we have a long-term viability of this amazing drip irrigation technology. In summary, we're pretty excited about this. Could take over 100 million pounds of single-use plastic from going to a landfill each year in the United States. It's really only coming together due to the work that the IIC is doing.
I'm interested in the irrigation research that the National Renewable Energy Laboratory is doing here, because I think that's going to help our site for better learning how much or how little water we need to put on crops around our plants that we grow out here.
A major goal of ours is to understand the trade-offs between how much water we might be saving compared to the changes in vegetation performance. We might see an increase or a decrease in vegetation performance depending on where that vegetation is in relation to the shade of the panel. This project is innovative for a few different reasons. One, this is the largest agrivoltaic research site in the entire country. Two, this site has not only crop production happening underneath it, but also pollinator habitat and native vegetation, as well as pasture grass that allows us to better understand the impacts of this partial shade on vegetation performance of different type, as well as on irrigation needs.
My hope is what we learn here at Jag Solar Garden will not only help us in growing crops better underneath our solar panels, but also help out other farms across the county as well as the state in figuring out more so of how much water is necessary for growing different types of vegetation.
The overarching goal of this project is to take a step towards center pivot automation. If we can move towards automation, then that could really reduce the labor requirement, and so we're excited about that. The overall goal of this project is to advance the technology in order to reduce the amount of water that we're using for irrigation. This project is innovative for a couple of reasons. I'm excited because this is a step towards automating center pivot irrigation systems. We are mounting sensors on the center pivot itself. We're taking advantage of the center pivot as a moving platform that already moves throughout the field and using that to collect data about the crop canopy. If the producer's not limited on the amount of water they can pump, it's really easy to put on some extra water as a cheap insurance policy to make sure they get a good yield. However, if they had more sensors and data available, they might be more confident pumping less water for irrigation throughout the year.
Been shown for a long time that soil moisture probes in the ground can save water. However, the adoption of those has really been stagnant around 10 to 15% for several decades, according to farm and ranch surveys. And so we have a problem with basically how do we scale up that kind of technology. And so this project wanted to look at basically, can we use remote sensing technology and still get some of the water savings that we would see with soil moisture probe technologies, and how can we use technology and actually transfer that to be scalable and adoptable by actual farmers on the ground is really important to me to actually put some of our research into action. Partnering with Darren Rudnick and through the TAPS program is a great way to do these side-by-side comparison projects, as well as get more exposure. More producers are going to be willing to take up this technology and invest it to see that there is an actual rate of return on putting some of the practices into use.
What we're trying to do is establish a straightforward way that we can estimate water delivery from electrical power consumption and electrical run time of center pivots. On a daily basis, we're collecting electrical run time on 15-minute intervals on every one of these wells throughout the year. And then using well calibrations, that's what we're doing here today, we're able to estimate water delivery. And the purpose of the project is to establish the accuracy of an approach like that because it has the potential to establish water delivery across an entire region. So we're collaborating with public power companies, Page Wireless, GISC, Nebraska Water Balance Alliance, and cooperation of the growers.
So growers try to really make themselves more efficient. And obviously with that comes a magnitude of data that is sometimes insurmountable. That data can and possibly be used against them in some instances. And so they're very hesitant about sharing it. The great thing about this data is that we keep it very private. It really helps us to help them better themselves in the long run. The data that we bring in can show a lot of discrepancies and positive things about what they're doing with their irrigation management systems.
Having more information just helps people make better decisions. If a farmer can have up-to-date daily information on not just his power consumption, but his water usage, that would be valuable, particularly if he's operating in an area where water is somewhat limited.
What we do is we research soil moisture with our soil moisture stations that are wirelessly controlled. Part of the reason that this project is so innovative is the low technology that we use, trying to keep the cost as low as possible. Also trying to keep the sensors measuring the environmental parameters to close to a research grade sensor. We've been exploring over the last year as founding a company, and so we have Soil Signal is the name, and we do a lot of the work that we did in the lab, but this time we're kind of trying to outsource some of the hardware fabrication and things of that nature so that the more people can get their hands on things that we use. Also, although we make our own sensors, we want to be able to use as many as possible. And so research grade sensors, things that already exist on the market, we always try to keep compatible with whatever we're doing. And so this year we focused primarily on improving the hardware, just making the experience a little bit easier and more streamlined.
Today, fertilizer comes from a factory 1,000 miles away from the farm and the Center for Irrigation and Technology farm in California. Fertilizer production today uses one major chemical process called the Haber-Bosch process that consumes coal or natural gas and leads to considerable greenhouse gas emissions from the form of CO2, methane, and other forms of greenhouse gases. And so we use a process that's similar in nature to lightning. Lightning can break down nitrogen in air, and rainwater can scrub it from the sky. We've done that, but we've packaged it in a system underneath the solar array using a novel process into liquid, so water-soluble nitrate-based nitrogen, and then sent it out through irrigation to the field. We're trying to increase the size of the hardware by a factor of about 20. From what we first tested at Fresno State to what we're testing now on a commercial farm nearby. And so our solar array is much larger. Working with Fresno State and specifically the director, Dr. Charles Hillier at CIT, was really important to help us understand what needed to happen to scale this and which key challenges that we had to overcome. In 2021, we are still working on the development of a much larger system tied to a standard irrigation set size.
In 2011, a Blue Tech Valley movement began, with a goal to accelerate innovation and growth of water, energy, and ag tech companies. It began in Fresno, but is now spreading across California through the Water, Energy, and Technology Center, the WET Center at Fresno State. Here, entrepreneurs have access to incubation, acceleration, and commercialization services. Grant funding from the California Energy Commission and the Economic Development Administration supports the Blue Tech Valley Innovation Cluster. We work with companies in 39 of California's 58 counties, ranging from central to northern California, from the ocean to the eastern border. To cover this geographical area, Fresno operates as a central hub with additional hubs located at the Sierra Small Business Development Center in Truckee, along with hubs at CSU campuses in Bakersfield, Chico, Humboldt, Monterey Bay, and Sacramento. Headquartered in California's Central Valley, our focus follows the needs of the region, which are primarily water, energy, and agricultural challenges. A unique, critical first step for ventures working to meet these challenges is a Technology Innovation Evaluation, or TIE. The TIE process begins with an application that helps us get to know your venture and learn how we can help. We encourage you to apply for a meeting. The TIE meeting provides a direct discussion between ventures and a committee of technical and business subject matter experts. It begins with a 5-minute introductory period and recognition of credentials. This is followed up by a 10-minute presentation of your technology or innovation, and then an open 30-minute Q&A portion. The committee will ask you questions, then provide feedback and recommendations. TIE meetings help the committee and the BTV team determine the best steps to move your company forward. These could include connections to product development expertise, testing labs, a Blue Tech Valley plan, becoming a WET Center member, or an introduction into our Valley Ventures Accelerator program. We are always excited to learn more about entrepreneurs who are challenging new frontiers in innovation and hope to see a meeting application from you soon.
Ready? Okay, so our first booth that we're going to visit today is Ranch Systems, and we're here with Hyland Kaufman. Hyland, can you tell us a few things about Ranch?
Sure. Well, we're really glad to be here at the AgTechDay and sharing a lot of the solutions and availability of problem-solving items for today and tomorrow, and that's what Ranch Systems is all about. So we've been in business now for close to 20 years. We've been providing telemetry for growers on a global basis. We were started here in California, so it is our home turf. But what we do is we manufacture wireless technology that is agnostic to the sensors and controllers and probes that you're using in your farming operation. And today we're very much focused on solving the solutions around some of the challenges like Sigma and SB 88 here in California, along with pest indices and labor heat index monitoring for growers, and providing you solutions all in one location that you can go to your app on your phone and have all the answers that you need with very actionable, detailed data without having to do spreadsheets on your own and that. And with that, I'm going to hand it over to my colleague, Terrence Jones, very quickly. I'm the Director of Business Development. He's the Director of Field Services, to talk a little about water saving and irrigation services that we work with agronomists on.
Thank you, Hyland. Yeah, thanks for inviting us. We're glad to be here at this show. So Ranch Systems ultimately is a platform for growers to manage their farms. We integrate with all of the top sensors on the market, and we integrate with a lot of sensors that growers may already have in their field. For example, Flowmeters. We have a suite of products that are designed to monitor just about everything on your farm, from weather to soil water status, even well pumping, well groundwater levels, as well as monitors for your irrigation system, environmental parameters. We're even coming out with an air quality sensor soon to monitor for some of the health conditions around smoke with some of the wildfires that we have in California. So just a general purpose platform for ag. We integrate with some of the leading sensor suppliers on the market, Some of them are here today, SeaMetrics, AquaCheck, Sentek, and we work with a network of dealers. So we are the telemetry and cloud platform maker, but we also take special care to integrate nicely with third parties. We work with our dealers who are generally agronomists, crop consultants, and irrigation companies. And we work with them to bring the full package to the grower. So we are the telemetry and sensors piece. We reliably get that data from the field to your smartphone. And then we work with a network of resources to help you farm better and use water better.
All right, thank you very much. We're glad to have you here. So let me pass this back to Bill for sanitation, and we're going to move on to the next booth. But Valdemar is going to take a moment just to pan around the booth so that everybody in TV land can see what Ranch has got on offer today. Yeah. Okay, so we're on to our next booth vendor. This is REDtrac. Please introduce yourself. Tell us a little bit about your product.
Sure. Hi, I'm Justin with REDtrac. I work for REDtrac, which is a company owned by SeaMetrics, and we do monitoring and automation solutions. We started in wind machines out in the citrus, but have branched out into pump control, valve control, things of that nature. So we offer a very user-friendly, very simple system that allows you to remotely start and stop your pump, schedule irrigation events, monitor and totalize flow from Flowmeters. You know, some of the other things that are important to a grower at the irrigation site. And one thing that we hang our hat on is that it is a user-friendly solution. It's all cloud-based, real-time data direct to your phone. Alerts via text or email should you have a device go down or something that you need to send workers out to address in the field. So anyway, that's the heart of what we do, and like I said, also valve control. So we feel like we can be a complete solution for the grower, and we're being used by several of the larger growers here in the Central Valley. We were recently acquired by a company called SeaMetrics, and SeaMetrics has a water solutions division with soil moisture probes and pressure transducers and dendrometers and all of that to the dashboard on your phone to also give the grower just more information real time. And I think that's the goal for the company as a whole, is to be a one-stop shop for grower solutions with you know, in the farm of the future sort of setting.
Great, thank you very much. Would your colleague from SeaMetrics like to say anything?
He did a great job.
Okay, great.
Okay, thanks.
Thank you.
Thank you.
So as Bill's sanitizing the microphone, we're going to move on to our next vendor, who is SweetSense. We've got Matt. Matt, now that you have the microphone, please introduce yourself and tell us a little bit about SweetSense.
So I'm Matt Tolbert. I'm the Chief Business Officer at SweetSense Inc. So SweetSense basically developed a universal satellite-enabled gateway. So we can do any type of environmental sensing anywhere on the planet. So, and we can connect to the internet and get these installed usually in about 20 minutes. So I have it flipped over here, but under the back is kind of where the magic happens, so to speak. We were one of the first, or the first company in North America to use Swarm technologies. That's what that first large silver tile is. That's their modem. Swarm is the first company to commercialize a low-cost Internet of Things satellite network. So they put satellites up in space, and they provide a really low-cost service. Other satellite network or other satellite services are 5, 6, 7 times more expensive. So Swarm, by being so cheap, gives us the ability to unlock a lot of potential use cases and value for agriculture. 3 lithium-ion batteries, those are basically the same batteries that are in a Tesla vehicle, except they have about 2,000 of them. We have 3 of them. And then this modem down here is a little in-ocean radio. What happens is I do something like I'll go up. The main thing that we do right now is we save customers money on their pumping costs. about 20 to 40% on their electricity bills. So I open up your electrical panel on your pump. I clip this around one of the lines serving the pump. It's connected to a wireless transmitter. This wireless transmitter communicates to this box, to this gateway via this modem right here and Ocean. And then they take that data and through the swarm modem and uses this antenna and sends it up to space and to the cloud, where we clean up the data and we send it over to our partners here at Wexus Technologies. Wexus has been a market leader for a few years now in ag. They've solely focused on saving farmers energy on one, their pumping, and two, making sure they get an ROI on their solar installations. So we partnered with them, we send them the data, and they give customers a very high quality dashboard so customers can really say, how much can I save on my pumps? They get alerts, text alerts, email alerts to let them know, hey, if you keep running your pump into this peak pricing or into time of use pricing, that it's going to cost you $836. It's very, very specific, and they help you make a monetary decision about your pump savings. So that's the first thing we've done as we've kind of entered the market. We just closed our Series A financing last week. So just kind of brand new, don't have many marketing materials as a result. But yeah, I got the sign made in Tulare when I was doing some installations this week. So at Bill's recommendation. So yeah, that's what we do. Very, very simple. I install all this in about 20 minutes. There's no trenching, there's no wiring. I strap this usually to your utility pole with banding that they use to make street signs. So like I said, I just did 20 in 2 days down in Tulare, Madera, and Merced. And I did it. We do a pump test as part of it. So I do a pump test, do my installation in 30 minutes, and we're out. And then, we're pretty much real-time data that we can send to Wexus and help customers save a lot of money on their pumping. So
Great.
That's kind of the first use case. Next year, we're going to be coming out with probably even more innovations. I don't want to let them out of the bag yet, but more innovations to help farmers make money on energy savings. And then actually we have a new technology to help them make money on carbon credits and carbon sequestration. So we're really focused on saving or making money for the business at the farm.
Great. Thank you, Matt.
Thank you. Appreciate it.
All right. I'm going to pass the microphone back over to Bill. Thank you. And Valdemar is going to get one last look at what's going on at Sweet Sense booth. And then we're going to move on over to Umida with Joseph Gallegos. Joseph, please introduce yourself and tell us a little bit about your product.
I'm Joseph Gallegos. You got the volume?
Yeah.
And the name of the company is called Umida AG. We're a new type of subsurface irrigation system, a new type of irrigation category. The thing you should know is that our business model is that we actually give this system for free to the farmer in exchange for managing your energy and your power and your water. So as I explain it, I think you're going to find it very interesting. So what we've done is we've put a subsurface irrigation below the surface, 5 feet below the surface, and orchards, and we're feeding the trees from the middle of the row, and that will create a moisture plume. A virtual water table is actually what we're doing. And that water table plumes up, and the trees feed from that water table. So we're cutting water by 80%. So this last year, we actually produced an almond orchard crop with only 8 inches of water as composed to 50 inches of water. It's a completely revolutionary way to irrigate. And so just show you some of the water savings and kind of zoom in on that. So what we're seeing there is that 7.8 acres inches, and we produce per almond is only 0.14 ounces compared to 1.1 gallons on the current traditional irrigation. And this is the irrigation system itself. So water flows through these side channels, and then it comes out holes that we actually drill in the side here, which would be orifices. And then this center section fills up, become fully saturated. And when it's fully saturated, it then allows the surrounding soil to wick it up, and it wicks it up 5 feet up and actually 10 feet on each side. And that moisture plume is where the trees actually feed from, not the pipe itself. The pipe itself stays saturated so that as roots come towards it, they stay away from it because it's too wet. They'll go to wherever the nice moisture to oxygen zone is. And that's us, UmidaAG.com. Thank you.
All right. Thank you very much, Joseph. So I'm going to hand the microphone back over. We're going to walk on over here to Jim Finney, and he is going to tell us a little bit about his product. So once you get the microphone there, Take it away.
So I've developed some solutions to reduce energy and water usage at the filter station. A little bit closer,
Yeah.
is that better? You want me to start over?
You're good.
Okay. So what we've done is we've come up with a solution that removes silt. And really, there's no other product on the market right now that can remove
We're not
silt
going to be able to
from,
see your face
from
with this,
irrigation water. And it's a
okay.
real issue, particularly this year, because of the water sources and the over pumping of the wells. And so that allows us to eliminate high frequency or continuous backwash. And then those are very low energy users, as well as our media filters. And so our media filters are set up to operate at as low as 15 PSI inlet pressures, which again is maybe 20 PSI below what the industry standard is. So everything is geared towards saving water, saving energy, and increasing water use efficiency. In other words, the productivity of the crop.
Thank you very much, Jim.
Okay.
Let me take the microphone. We're going to hand that back over to Bill. And we're going to walk right on over here to Airstone.
Thank you very much.
And make sure you hold it close.
Will do.
All right.
Okay.
So please introduce yourself and tell us a little bit about your product.
Thanks very much. My name is Bill Moffett. I'm the president of Airstone Productivity. We make Wi-Fi for farms. The idea being it's the same Wi-Fi that you use in your house, but you can extend it out over your acreage up to tens of thousands of acres. The big idea was built from noticing how much data there is involved in farming some years back. And we wanted to make an IP network, wireless, that farmers could use and control on their farms so that they'd have control over both the network and the data as it was going out. We came up with these. These are called the Air Mesh Hubs. They are just meshing Wi-Fi access points. The big idea going forward is that this forms the backbone of farm automation, both large for autonomous tractors, things like that, and small, down to little sensors that you'll be putting out in fields to take measurements and things like that. And you know, the thing we're trying to do is make this as simple to use, easy to set up, and affordable as possible so that any farmer can use it.
Okay. Thank you very much.
Thank you, sir.
So we are now going to move on to our final booth interview. And we are here with How Neat and Daniel. Daniel, please introduce yourself and tell us a little bit about your product.
Thank you, Dr. Hillier. My name is Daniel Howe. I'm with How Neat. And with How Neat, we're a product development company for AgTech. This year, actually just yesterday, we announced our new subsidiary, which is Neatmon. Neatmon is an open development platform for agriculture, and it features both hardware and software that enables companies to scale and provide more solutions to farmers. For example, weather stations, flow meter monitoring or reporting, and irrigation control. So basically what we're filling the gap and need for is to be able to add sensors in the field as a grower needs it or as a solution requires. And that's something that we see that we don't see a lot of solutions for, the ability to add additional equipment and to be able to monitor that. And furthermore, on our monitoring equipment, we actually have a patented notification light. So if any sensor meets a certain threshold or it detects that there's a problem with a sensor, you can actually change the color and notify personnel on the site. So if you can imagine you're driving down the road and you are looking at the crop, you can actually see in the field if there's problems. So for example, a frost alert, you can see a flashing light, and that brings the attention to that area as a place that needs attention.
Okay.
That's How Neat and Neatmon. Thank you.
Thank you very much, Daniel.
Thank you. Any questions on that?
I don't think so. We're having a little audio trouble, so no questions.
We have, okay.
All right.
All right.
Thank you, Daniel.
We're going to take a little cruise around and I'll try to narrate it real quick and then we'll come back to you, Charles.
Okay.
to close it
So,
out. Or you can do it if you'd like.
no, why don't we let our cameraman Valdemar go through the booth land?
Yeah, we'll go
and
around and at least show everybody as we go by.
Bill Green will narrate as he's walking through.
All right, sounds good.
Thanks,
Then
Bill.
we'll see you back in a few minutes.
All right.
I think I got a few slides to finish out at the end. So we're looking at the different sites here. This is GroGuru Soil Sensor Company. Okay. Just wanted to point it out to you guys as we go by. Then we have Mazzy and Chemigation Injectors. Mazzy's does a lot of injection for chemicals and stuff. Then we have the California Almond Board, and so they're here today at the site. We have a couple people talking to them. We have REDtrac monitoring station here. He's not in the booth right now, but he's next door, next to talking to the FiTech people. So REDtrac he was here earlier today, so you got to hear his talk. And this is FiTech, another company that's showing here today, again, showing growth and rooting and things like that. Okay. And we have FloraPulse. This is FloraPulse, and he's here today showing his hardware that he can show stress levels and things like that, I assume, with your device. Water potential. So you're going directly in the trunk for water potential. Very interesting. Okay, good. All right, we're just going quickly by telling everybody. We have Verdi, which is water and nutrient delivery for every plant, and they've been the show today, so they're got their equipment here. Getting a lot of feedback. Okay. Then I've got the International Agri Center here. How are you doing today? Hey, good to see you. And they supplied the water bottles to everybody today, and we appreciate that. And they got some hats and things here, and we thank you for coming and being a sponsor of today's show. And hopefully everybody goes in February, because we are going to have one. What are the dates this year, by the way?
The 8th through the 10th of February.
8th through the 10th. That's about as early as it can possibly be. I think it's always the second Tuesday, and so 8th would be the second. Okay, got it. It's an early one this year, but everybody hopefully will be back. So I'm sure I'll be there. Here's Wild Eye. They've got their different monitoring systems and stuff for pumps and irrigation systems, sensors, flow meters, all that. We're not really doing interviews. We're just talking and showing everybody. We got our mobile education center here from Fresno State. This is part of CIT, where we do workshops. We do, hopefully you're on our mailing list, our email list, our listserv, and you can see our events that are coming up. We got a pump efficiency event coming up in a couple of weeks that we'll be doing on November 16th. You can sign up through PG&E or directly online through our listserv that we send this out. Next, we have Ag Monitor. Ag Monitor does pumping monitoring and irrigation monitoring, and has their own solutions for doing different energy and water efficiency programs and stuff. Hopefully I got that good enough for you guys. All right. Thank you, Kevin. Thank you, Fabian. Anyway, and next we have Jane USA. Obviously a big company, Jane, that's got here. They've got all kinds of monitoring and irrigation solutions and all kinds of good stuff, right, guys? So thank you. Hopefully you got a few people came by. Thank you. Then we have WiseCon. Hi, Sage. How you doing? Hi, guys. So good to see you. So anyway, WiseCon here is here today. They also do monitoring and control, irrigation sensing, flow meters, sensors, control remotely, and all this sort of thing too. So, okay. Thank you. Then we have, I don't know. Oh, this must be Don Wright. I see a guitar there. So I know this is Don Wright. Water Right is his website. I don't know where he is right now, but he's probably getting lunch. So, all right. We have Aerometer. They've been doing this for a long time. Aerometer has soil sensors, tensiometers, gypsum blocks, that sort of thing, watermark sensors. They have the whole monitoring and control of irrigation systems through soil sensors. So another site. Next, we have Rubicon Water that does smart water management. They remote sensing, control, weather stations, all kinds of different things you can get effectively through them. Hopefully I pointed that out pretty well. What is a picometer? What's a picometer? Okay. It's to measure irrigation district water at turnouts. Okay, I see that now. Okay, good. We need one of those on campus here, actually, because the water comes through here and nobody knows how much it is. So through Fresno Irrigation District, we'll have to work on that with you guys. Thank you. Okay, finally, we have, what do we have here? Oh, TwoCor. Yes, of course. And you guys came a long ways, I think, for this, or maybe you're local. Out of Pennsylvania. I know TwoCor's out of Pennsylvania. You have different valving and other things. Flow meter, I guess, huh? Saddle meter. Okay. Very good. More solutions for managing and measuring water. Soil sensors, got them all. All right, good. They got the whole solution. So thank you. Sorry to interrupt. Next, we have pump side over here. Morgan Howell-Penny and Greg from REDtrac is here. You saw him earlier. We're just walking by and showing everybody. Again, you have monitoring and control solutions for farmers. And so we're just kind of showing everybody what's here at the show today. So still got quite a few online right now. So, all right. Next, we have Micrometer, the one of the oldest measuring companies with their different metering devices. I have a micrometer on my own farm, actually. So anyway, they're used for measuring water. So Pam's been coming to work with us for a long time. We appreciate you being here today. So micrometer, another flow meter company, I should say. All right, then we have Brandis Systems. You're Kevin, okay. All right, Kevin, you were on one of the buses. You have monitoring and control devices, I guess, for water management, system data and things like that. Is that correct? Yes, that is. Okay, good. So we just wanted to come by and show everybody. Okay, good. You bet. Here we have COS, College of Sequoias. Charlie Abe is the professor of irrigation there, and he's got some of his students here today, and he's got this cool pump trailer that I really like. He's got it running there. It's not wound up too much. Charlie, you got it going. We'll show this off. Mine's not running, but Charlie's is, and it's a cooler trailer than I got. So anyway, Charlie's here with his students today, so just we're letting the No, thank you for being here. Okay, cool. Next, we have TRC Company, and they have incentives for retrofit and repair of pumps, installing VFDs and agricultural irrigation settings, and other energy efficiency projects that they run for PG&E. They're the incentive rebate program at this time for PG&E. So they are talking to customers here. Thanks, Richard, for coming today. We're just pointing that out to everybody. Then we have PG&E next, which they have all kinds of goodies here. They're letting out here. You guys been giving any stuff away? Good. The cows are always popular, aren't they? Okay, good. Anyway, we're just going around to each booth and showing everybody that's here. We thank you for being a major sponsor today and really appreciate it. So, okay. All right. Thank you. And finally, we have the international, what it was, IIC. I can't remember what IIC stands for. I never can remember that. Why? Too many acronyms. Irrigation Innovation Consortium. All right, sorry guys. And then the CIT and the Wet Center and everybody that's here, they're here today.
And then Bill, don't forget Technoflo and SeaMetrics.
Yes, we're still going to go back over there to them. So we got one more booth to see after this, but thank you for being here today. Appreciate it. And finally have Technoflo and SeaMetrics. And we just want to say thank you again to one of our major sponsors today with the buses there. Thank you guys for coming. Flowmeters, obviously, you guys heard all about it. Steve talked about that earlier today, and we'd really appreciate it. So anyway, we've got to grab some goodies before he closes up here, Valdemar. So anyway, thank you for being here today, guys. All right, take care. And I think we're going to go and we got a few slides to finish up, I think, for on the online audience to get their hours of CEUs. Should I do those real quick?
Yeah, so you're still broadcasting. Why don't you tell them how to get their CEUs, and then we'll say
Grace, do you have those slides to put up, or? All right, there they are. I'm walking back so I can see. I can't remember what I wrote, so I better go read the slides. All right. Anyway, okay, go back to the one before. There we go. No, the one before. Oh, that one's good. All right, so if you're a certified crop advisor, you're eligible for 3 hours of CEUs today. Just email us now. You were supposed to email at the start of the show. We can see when you came on from the virtual audience, but cit.ceu@gmail.com, cit.ceu@gmail.com. In that email, include your first and last name. That it should say 3 hours of certified crop advisors. That's a typo on my part. I had it on there, I thought, right, but I got it wrong there. Anyway, we need your license number and your phone number. So you will be eligible for 3 hours if you're still online, even if you left a little while ago. But if you hopefully you got this message and you'll do that. Next slide, please. Next slide. That's not the right one. There we go. And if you have a nitrogen management plan license, like I do for my farm, I needed the hours today, and since I wasn't the speaker, I took advantage of that, and I've got you get 3 hours through the FREP INMP nitrogen management plan program through CDFA, and do the same thing right now. Email cit.ceu@gmail.com, cit.ceu@gmail.com. Put your first and last name, your request for 3 hours. Again, there's another typo, missed that somehow in a hurry yesterday. your address, your phone number in case I have to call you just to double check, make sure everything's good. And I want to send you a certificate. We'll do that after the fact. And also your sub-basin or coalition. For example, there's East San Joaquin Water Quality Coalition. I'm a member of the Kings River Water Quality Coalition. So you just have to know that. Send us an email right now so we can sign you out. But you should get your 3 hours today. It should help you with your licensing for the year. So anyway, I'm going to hand it back to Charles now, and he's going to conclude this today for us. Thank you guys.
Okay, everybody. Well, thank you for joining us on the AgTechDay 2021. We're really glad you could be here, especially those of you who stuck through all the way to the end on the virtual presentation. The trade show is going to go on for a couple more hours, but if you happen to be watching this as a recording and you can't find any of the links, please go to our website. You can find contact info for all of our staff. Just reach out to us and we can connect you with any of the information that was presented in this meeting. So again, thank you for joining us, and I hope you have a great day.